It's live, I think.
Want me to check?
No.
That means live. It says live stream offline.
Offline.
Let's get some work done. I somehow doubt it.
We're gonna get something done. It's gonna happen. It's gonna have to happen.
I mean, we could give up on the display and just start coding other stuff.
No, we should make the display work. Also, my are you serious? Camera, it's now at 10 FPS.
It's dark in here.
This is just, uh-oh.
Hold on, I got some other lights.
It just crashed.
Too slow?
I don't know, something's hosed.
There's no room to move anymore.
This is so bad. Okay, not existing. Create new?
What?
No. UVC camera, camera 1. Let's try 640 by 480, 30. Hello? Okay, that didn't work. Christine, would you mind at least popping it open on a laptop so you can moderate chat?
She's like, nah, I got it.
Let's try plugging the webcam in a different port here.
It just says offline. What's going on?
Mine says live. Oh, there's a lot of people in chat. Am I live or offline now?
I think you're live. Yep, you're live.
Uh-oh. Oh, hey, there's a UVC camera now. You have a laptop? You don't be quiet. So I guess this can go down here for right now. I just want to let everybody know that, are you in the live stream? Almost. Don't whisper. We're doing this live stream from Josh Allen, Axle Crusher's house. He's the one who's been doing the configuration subsystem. I'm also trying to sell him a Vive from somebody at work, but we're having trouble with that because for some...
My computers are crap.
Yeah, well, okay, all the computers are awful here, and for some reason, he has a house that is, like, bad for the Vive, and I don't understand how this works, but he's got this area over here, which is, like, a huge area, which is great for the Vive. Like, look at this whole area. And the walls are made out of, like, this panel board stuff.
Is there a big delay?
And, yeah, there should be about a 15-second delay.
Oh, okay.
Which is like kind of reflective or something, I'm not entirely sure, but it's just terrible. There's like echoes and stuff of the Vive and it's just does not, I don't know. We're gonna have to figure that out and try to figure out what's going on there. So right now, Josh has his laptop there on the floor. And it's a Asus laptop, and we're right now trying to hack EDIDS in order to get it to output to the HTC Vive. Because, do you want to take that and show them what options you get normally?
So normally I am only getting 2 options for a resolution to output at, which is either 640 by 480 or 720 by 480. It also seems to be ignoring my mode lines.
Yeah, we're not really sure why. And so I think it has to do with something about like the max clock of his laptop not being able to, can you guys see that? I can't really,
Well, I'm watching the delay, but yeah, you can kind of see it.
Okay. I mean, I think that that's kind of there.
It's weird with the delay. Yeah.
So we're right now trying to figure out some way of hacking the EDIDs in order to do the right thing.
Do I need to point the camera in a different direction?
I don't know. Should you? I don't know. It looks reasonable to me.
Fine.
You guys okay with that Oh, I guess you can't really see me. I can see you. Maybe a little bit towards me. That's enough. There we go. So HTC Vive EDID Charles EDID. What did I name the file?
microphone's still down here.
What was the name of that file?
Charles, you did?
Oh, it was just Charles_EDID.dat. Okay. Can you guys see that text clearly online? Is that is this readable?
I'll tell you if people respond.
Okay.
No.
Can you read the text that is on the left?
Yeah.
Okay. Good. Let's see.
There's just a big delay.
It's not more than like 15 seconds, is it?
No, it's just weird.
Okay.
Like you do something and then like 10 seconds later it's on the video. People are saying yes, readable. Yes,
Okay.
Kenneth's readable.
Good. So this is what an EDID set or an EDID descriptor looks. Let me shrink that back a little bit here. Yep, that way would be good.
Here, have a chair.
Okay.
Okay, so this is just an EDID descriptor right here. And what I'm going to do is I've been just kind of like arbitrarily changing them. Do you remember what the command was? It was like read EDID? No. Something EDID.
Someone said, are you using your new PC?
I'm using my new PC. It's sitting just out of view down there. Actually, Christine, if you want to take the camera and just aim it down.
Like, towards that?
Towards the computer down here. You can loosen it up using the nut on the side. There you go. Yeah, right here. New computer. You want to bend it back up? Or, I don't know.
Yeah, I was just going to see if it.
Oh, got
I
it.
actually
Okay.
got it in the video. Okay. Maybe I'm back on you.
Sure. EDID-decode. Charles EDID. Okay. And so when you run this on the EDIDs, it gives you this information about the EDID descriptors. And this is information that's normally stored inside of the HTC Vive. But if you go into NVIDIA settings, you can then go for like the specific screen.
Someone says, what are you doing?
We'll be kind of going over what we're doing as we're doing it. Well, right now we're actually trying to get the HTC Vive to run on Josh's old laptop there. And by run on the Vive, I mean just output to the display, like at all. Anything would be fine. It's very frustrating. So anyway, you can click acquire EDID, and you can do that on the Vive itself, and that works fine. And so we have that now. And so I'm trying to edit the EDID in order to make a mode appear on his computer that would actually like run. Oops, that's wrong. There we go. So.
Josh, should I just put it on Charles now?
Nah.
Yeah, I guess you can just leave it as is.
Alright.
So what I started doing is I started changing these numbers willy-nilly. Like, instead of it being 74, I'll change it to like 32 and save the file out and then run this. And it, complains about the wrong checksum, but you can see that it changed the clock. And what was the other one? It was parse EDID?
I think so.
Or EDID decode. And so you can see here, it'll actually tell you somewhere.
Up at the top. Up here.
Is
Are you
that it?
checksum? Or
No, I'm looking for... Oh, that's a different thing. No, I'm looking for something E did. No, it's parse E did. Yeah. No. Yeah, I don't know. There was something that'll actually tell you what hertz screen refresh this is if you operate 128 megahertz pixel clock. I can't remember. There was like a different. Was it read E did?
maybe.
No.
Someone said, is there a succinct summary of what is going on?
Nope. No succinct summary. I mean, actually, ask them. Would that be like
I
a?
don't have a thingy.
You can type. Oh, I guess I should ask. Somebody asked if there's a succinct summary of what's going on, and the answer is right now no. But is that something I would say to you, or is that a document that I should be writing somewhere, or something I should write into a description? If you can just answer that in chat, that'd be awesome.
And someone says, look for CRC.
Yeah.
We did. It took us a while to find that. It turns out there's a tool called edid decode that when you edit it, it will actually tell you what the checksum should be. So we've been kind of blundering around in the dark until I found this one. It's like, oh, hey, by the way, you should change your checksum to 0x20, and then it'll parse. So right now we've been trying a couple of different modes. So 128 megahertz, that was like too low or something, right?
Yeah, he said I was mostly just wanting one of the knowledgeable people in chat to answer.
Ah, gotcha.
Someone said just Google LibSurvive. I'm sure you would try that.
Yeah, that's not going to tell them what we're doing right now. Oops, clock 040. That's not right.
Someone said, from what I've seen so far, they're trying to hack the Vive to display their output onto a screen of some sort.
Yes.
Someone said, why is changing the clock rate going to help output to the display form old laptop?
Okay, so the problem that Josh's laptop has is he can't output to the Vive because apparently he has a max pixel clock that is lower than 297 megahertz. So the goal
It
is...
says for my main screen it's 300 megahertz, so I don't know what the deal is.
Maybe it's just your HDMI output.
Maybe.
I don't know why. His laptop just doesn't want to do it. So we're trying to make it so his laptop will send junk to the Vive at a lower frequency that might be good enough to work.
So I could use my desktop, which is upstairs, but Charles has stolen the monitor for it.
If anybody's near California, Maryland, and has a monitor, we would really be appreciative right now because we just don't have any way of making this
I want
work.
people showing up to my house on the internet.
Really? I'm sure we could send them out somewhere and we could meet at a common location and get the monitor that way.
Yeah.
Oh, that's weird.
What?
I just did something and it massively broke. I don't know what just happened there. Anyway, so not 128. Let's just try 204 and see what that does.
I think I'm also going to try this allow non-60 hertz DFP mode.
Okay.
See if that breaks.
DE, so the checksum should be 02. Let's see if the checksums, so the checksums are valid. So what I'm going to do now is I'm going to go give this to Josh. We need a pen drive because I can't pull open Gmail while I'm live streaming.
Someone says you just need that Prime Now feature someone was talking about in the voltmeter stream.
Prime Now? I don't know
We
what
Oh,
don't
you're...
have that down here in the boonies.
Oh yeah, no, this is not near Baltimore. This is an hour and a half away from maybe 2 hours from Baltimore. Actually, I have a USB drive upstairs. make sure nothing is on this drive?
Sure.
If it says it needs to be formatted, just format it. Yeah, the other thing that's really confusing to me is it says that the max dot clock on the Vive is 290 megahertz, but it specifies clocks that are way above
It says this folder is empty.
Okay.
Oh, this is a
Okay. And so if the max clock is 290 megahertz, but all of the modes are specified for 297, then how in the world does the Vive work at all? Like, I don't get it. So I'm gonna go copy charlesedid.dat and I'm gonna go give it to Josh. Here you go. I'm ready to get more light on Josh, maybe. Christine, do you think that light could go like over here, maybe?
The lamp?
Yeah. Get a little bit more light on Josh, because I'm bright enough now, but. Okay. So Josh is right now going to take this file. Okay. I hope I'm online now.
Is it on?
Whoopsies. We had a bit of well, okay, Josh's wiring is very confusing, and bit of a confusion here, and we had a light switch that got turned off, which killed the computer and everything. So, okay, let's pull all that back up.
Don't ask me to do stuff.
I thought it was the last 3 streams now we had a power failure of some kind. Useful files. Charles Edid. Okay, so what do we, was it read? No. Parse. Edid. Charles edid.dat. Oh no, that's the wrong one. Edid code? I always get them. There's like 8 edid tools and only one of them does what I want. Okay, so 204. Okay, Josh, how's it going?
Alright, I'm restarting X11 right now.
Okay. Moment of truth here. Okay, booted. That's good.
You were recording my password.
Oh. Go, type password. Okay.
No, it's only a password I used on this computer.
You can't even see anything, Josh. You worry too much.
No, it is reasonable.
No, well, it's like not focused enough to even see anything.
Okay. Is it focused now?
No, I'll have to wait for the
Okay, so here's the cool thing. So now the HTC Vive shows up. You can select the, what I'm going to do is, can I dismount this, I wonder?
Alright, whoops.
Okay. 62 hertz. Okay.
So that's what we tried to do last time.
Yeah, click apply, let's see if it's showing up. Oh, you tried 62 last time?
No, that's what we tried last time.
See, I think people feel my pain.
Nothing. The Vive is still very sad. Can you set it up to use the, whatever it is, the resolution we know does work?
Sure.
Okay. So now, if you look in the eyeballs, the one just lit up. But that does mean that the Vive itself looks like it's just ignoring us if we don't talk to it fast enough, which is annoying. What do you think? Just up it some more and see?
Yeah.
Okay.
Yeah.
We're gonna up the.
So it's interesting. It's listing it. We're able to list something higher than 60 hertz, but it won't list 90.
Hmm. Um.
75.
Okay. Well, sure. Let's try 75 hertz and see what happens. I've forgotten which field that was. 78? 88?
These people are backing me up and saying that houses are like that. Things are just plugged in.
Uh-oh. I done goofed it.
Alright, people, get back on topic.
Oh, I need your. Should you need a thumb drive?
Oh, something's really broken here. You know what I'm going to do is I'm going to open up the Vive one and then...
Did it die in the power outage?
I don't know. It has the wrong number of bytes, so it's super wrong. Don't worry about it, Christine. That was what, like a 5-minute hiccup? 4-minute?
Not even that.
Like a minute, but still.
Everyone in chat, be sure to tell Christine how much you don't care about the fact that the power went out briefly.
You don't have to do that.
Useful files, HTC Vive. Uh-oh. This is the wrong number of bytes. Can you pull the Vive Z did for me again and copy it to the USB drive? Something's really wrong. Oh, wait, I could just get it from GitHub.
I can give you the last file that you gave me.
Check. I can just get it from
No,
GitHub.
it's still on the drive. It's still on the thumb drive.
Oh, yeah, that's a good call. Okay. Well, let me just check it out first, because I might have had the wrong number of bytes in that anyway.
People are arguing with each other.
About?
Well, people are going on about how when you plug stuff in the house and you can blast the light off, and then another person said stop talking about that. I was just talking about the Vive.
All right, you guys want to see what happened? There's a light switch over here,
Josh, stop!
which is connected to an outlet. So
Josh,
that's what happened.
stop.
I
Yeah,
didn't
no, my
wire the
stuff's
house
all
that way.
wrong. Can you just pull the... Here, we'll show you guys how to pull an EDID. Plug this in.
Get off topic.
So Josh is going to come over here. Oh, you know what? You're using a custom EDID. It's probably going to pull the custom EDID.
Probably. Why didn't you just use that one?
I tried. That one has the wrong number of bytes. So
That's
something's
what
just wrong.
That's what I used to start this thing.
You want me to just keep editing it? I guess we'll just keep editing it.
Oh, I have it over here. Can you turn the camera away?
Okay. Oh! I guess you didn't want to be on it either.
What?
Okay. Here, enjoy the scene of my computer. We'll run color chord on that momentarily.
Why am I in video?
Okay, so you have that now on
Yeah.
drive? Okay, let's plug this in here. And let's take a look and see if that file is all wrong. Oh, it doesn't see it. Or something. Kingston, edid.bin. Oh, it had the right number of bytes. I had to set the width wrong. There we go. Okay. Everything's fine anyway. Let's save this into Charles E did replace.
What would 250 megahertz be in terms of the refresh rate?
So 250 megahertz would be. So okay, if the current one, what is it? It's 297 is 99 FPS, or sorry, 90. So 297, 90, or the 7 times 250. That would be 75.75. So we could probably do 75 and try that.
All right, I'm betting as soon as we go over 255 megahertz, it's probably just not going to show up anymore.
I figure if it's not going to work at 75 megahertz, it's probably looking for exactly 90.
Probably.
Okay, so let's just look.
Someone said, doesn't the NVIDIA driver have a tool to create custom display profiles?
Does it? I've never heard of this. In chat, can you link? Oh, I'm not even in chat. Oh, wait. Maybe I'll be in a second.
You mean a custom screen?
Someone said, is that a black eye?
No, I don't have black eyes. I just naturally have.
Black eyes.
Yeah. Especially when I don't sleep well. So in here, let's see, what is it right now? 253. So that's 63 is 253. What did you say it was that you needed? 250?
250 or 250? 255 is what it says the maximum is.
Okay. 299 divided by 90 times 75
I'm
is
thinking
200.
this might be a limitation of the HDMI port.
Yeah, we are worried that Josh's HDMI port could just be sad.
Someone answered the NVIDIA driver and said, yeah, but it's just for games.
Well, we're kind of like a game, right? So 248, 320. I don't actually know what the conversion here from hex to megahertz is, but you know, I'm just guessing. 249.6, we're getting close. It is 248.96. Okay.
That's what it was last time, wasn't it?
I don't think so. 249.2. So it's got to go a little lower, so maybe 58. 249.2. 57.
Isn't that how you know it's turned up though?
It's already on.
Oh, that one's for one.
249.17.
Oh, so lamps for that's finished.
249.16. So let's just do 17. 17 looks closest. So then what I'm going to do is I'm going to then check some, should be A0, and that's this byte right here. Uh-oh. Okay, now let's make sure they all work. Valid, valid, okay. And I'm going to go copy this to the USB drive again. And eject it and give it back to Josh.
Someone said, are you changing random byte or what?
So what we're trying to change is I just kind of experimentally found that these few bytes right in here, those 2 bytes control the pixel clock, which is this number right here.
Still Charles E did?
Yeah, it's still Charles E did. And this number right here controls, I'm guessing, how fast that shifts the data out the HDMI port. I actually don't know that much about HDMI. So I'm still trying to figure that part out. But we have found that Josh's computer just absolutely will not output at the 297 megahertz that the HTC Vive has in its display modes, which is a 90 FPS signal. And so right now we're trying to knock the FPS down that we're sending to the Vive headset in order to make it so he can actually output to it on his computer. So if all goes well, we might have the only HTC Vive that operates at 75 megahertz ever. But for all I know, HTC might have made it so the display just won't work unless it's at exactly 90 FPS. So this could all be a bust.
What was the megahertz reading on that file?
The megahertz reading on that file was 249.170 megahertz, which works out to 70 divided by 297 times 90, 75.5 hertz. Did I do the math here wrong? I think I did it wrong.
No, it can only go up to 225 megahertz.
225. Weren't we higher than that before?
I don't think so.
Uh,
Of course, now it says my native display on the laptop can do 330.
What? Wait a minute. Change the resolution of your display on the laptop.
Just downwards.
Yeah. If this works, I'm gonna laugh so hard.
Someone said, what is this strange apparatus Charles is sitting on?
A couch. Most homes have them.
Oh, never mind. I got all excited because I saw output on the Vive. Okay. What is going on? Oh. No.
Yeah, that file doesn't work at all.
Try reducing it further. Oh.
No, it does that when it starts up X11.
Maybe if we keep rolling the dice.
Well, that's not right. But see, that's saying
Oh, let me bring this over there. So we're looking at his DFP. It says DFP-1 is 165.
well, that's disconnected, so that doesn't count.
Oh, okay.
But the Vive is on DFP2, and it's saying 225 megahertz.
I'm curious, just run it again and let's see what the log file says.
Alright, whereas the internal display of the computer says it can do 330. So it might be a limitation of the HDMI port coming out.
Just try running it again. I'm really curious to see if that changes though. So you said it was not 225 before.
I think that's the maximum I've seen for it.
Okay, but you've seen a different number before.
Yeah, lower, like 165 or something, when
Oh,
things are not working right. So yeah, it still says 225.
225, okay.
So.
So let's just, what if we just make it 225? Just see.
Okay,
Okay.
that's the best we can do. But it looks
Yeah.
like if it's any higher than that, it just ignores the modes.
Okay. Give me a, give me a second. So we're gonna do 225 now.
I guess if this doesn't work, we'll just move on with something else.
Yeah, I guess. Actually, you know what I think we can do? I think I can switch it to programming mode. I'm guessing if I write 22500 57E4, let's see if that works. Oh, wait, it would be E457.
Yeah. Combined order.
Yeah. 22500. Ah, we don't have to do that guess and check stuff anymore. Okay. Oh, thanks. I need a, like, I have a USB hub. Hooray. By the way, if anybody knows how to find out what the max pixel clock is on the HDMI output on a Raspberry Pi, that would be super cool, because I would love to know if it's even technically possible for a Raspberry Pi to output at the needed resolution. Charles E. did. Replace. Oh, you know what? Let me fix the checksum.
Okay.
So that's A0 should be 1B. Let's check it. It says checksum is 1B, valid. Okay, so copying that over, replace, eject. Okay. Try this. But now I'm really curious. What is up with it when it says what its maximum is? Well, Josh is going to try this one. Let's take the screen over and watch him. Is everything okay in chat?
Mm-hmm.
Okay. Oh, you're going to...
Away?
Yep, it's looking away. And it's back. Live is not showing any signs of life, so this may be a bust.
Probably.
Yeah. 68 hertz.
As high as we can go.
This is as high as we can go.
Someone wrote HDMI EDID monitor range, vertical is 4862 hertz, horizontal is 1468K hertz, max pixel clock is 150.
Okay, I'll have to go.
This is for the
Raspberry
Pi.
Pi.
Oh, cool. I'll look at that real quick. Because I just want to know that, but that doesn't actually help us solve this problem at hand.
Oh well.
Christine, do you think your dad would have an extra monitor somewhere at home?
No.
Let's see chat. So he says 150 megahertz. So close! Wait, that's not so close. That's a long ways
A
away.
long ways away.
Wait, how do you output 1080p 60 on a Raspberry Pi then? 1080p 60 is higher than that, right?
I don't know. Is it just pixels times?
I think so. Let's actually see. So if 225 megahertz. No. Was it 68 hertz on your computer?
Yeah.
Okay, so that's how they calculate it.
Number of pixels just divided by clock speed.
Yeah.
Someone wrote reduced blanking, and then someone else wrote parentheses dot dot parentheses modes bigger than 1920 times 1200 at 60 are not supported.
On the Pi?
Man, come on, guys. I really wish. Well, at least you guys are now quelling my hopes and dreams before I have to get them quelled by force. Does anyone else know if there is another Raspberry Pi like object that that?
Which version of Pi is it?
Yeah, is that actually the right version of the Pi? Well,
1,
Josh.
2, or 3?
Josh, I think this means that you're gonna have to go back to menial
Yeah.
Pi labor or menial. Well,
Well,
I can get on my laptop.
LibSurvive works fine.
Yeah.
It's just I can't render to the screen.
You know what's crazy? My laptop can render to the screen at 60
Someone said
FPS.
RPI1 probably.
Oh, if somebody can look that up for the Raspberry Pi 3 to see if that's the same, that'd be really neat.
Someone said that newer versions use same GPU.
No, newer versions do not use the same GPU. Okay, I will check this though.
Someone said elinux.org
I'm
/RP config search for pixel block.
Google.
Your tape fell down, Josh.
I guess I can get some thumbtacks and thumbtack that tape up there.
Someone said Asus Tinkerboard does 4K.
Interesting. Well, that's probably where we're going next.
Sounds expensive.
Someone said if you need all the correct standard HDMI timings, get the CEA 861 PDF.
Yeah, it says right here, 1280 or 1920 by 1200. What is the Vive's resolution again? Watch it be like right on the cusp.
No, Vive is over like 2K.
Is it? No, it's 2160 by 1200.
Yeah.
So close. So is this?
No, it's still 30 frames a second off, even if it had the same resolution.
There's some more numbers on chat.
I'll go look at the numbers. Okay, we'll look into all these Pi things later. Okay.
Anyway,
We
should
have
we
to
bring
move
out the
on.
second Vive?
What are we going to do with that?
I want to plug it into your computer.
You know, we never tested the second Vive with your setup. We probably should test that on Windows. Maybe we should go back to broadcasting from my laptop, and then we could test whatever we wanted.
Someone said you also can't use reduced blanking on the Vive. Someone says what color depth factor. Someone says what about Odroid C2?
Okay. No, I mean, by the way, I have the chat up now, so I can see it.
Oh, okay.
By the way, Ben, that makes me very sad, but I understand. We will look into. I'll make a list of devices to look into. Let's do that right now.
Alright, time to go find video cards.
Wait, what? How am I gonna do this?
Well, that was fun.
I make the rest of this. Okay.
I just put the headset on above. That doesn't need it plugged in.
No, it doesn't need to be plugged in. The headset operates independently of you. I have zero service down here, Josh.
Yeah. AT&T.
Someone said how you did expert, but I doubt anything but the primary node is going to work.
Well, you get the 720 by 480, and you get the 640 by 480 modes, but oh hey, I got signal. Come on, GitHub two-factor authentication.
Oh.
Come on, I need that text.
Why is it saying that there's an echo?
Say what?
Everyone's saying that there's an echo. I don't have my sound on.
I don't know how there could be an echo.
Let's see.
What about now? Is there an echo now?
Someone said better.
Resend code.
Someone said it's good now.
Okay, come on, GitHub. Come to my phone.
Can't you just use like Google Authenticator with GitHub?
I'm not sure.
I'm pretty sure you can, because I did.
Better. It's still using the right audio device.
I'm gonna take your phone outside.
I mean, it should be fine. Can you text me? Because maybe that'll kickstart it through or something. or take my phone outside and text it.
Someone said Authenticator works like a charm with GitHub.
Yep.
Google Authenticator. What is Google Authenticator?
It gives you those one-time rotating keys, like every 60 seconds or 30
okay.
seconds or something. I did send you a text.
Oh, okay. You might want to take it outside then. How short is that guy?
Well, Josh was on his knees, and it really looked like a really short person. Because I was like, why'd they say that?
Okay. It's this tab. And actually, I should probably check. Nothing. Okay. Oh, that's right. I can't actually create the issue until... I was just commenting to Josh earlier today that when we were young, because we were actually roommates in college, whenever we would have something we wanted to do, we would just start working on the problem at hand. If it was coding, we'd just start coding. And we would finish coding, and we'd have 9 hours of coding in a day, and it'd be great. But as we got older, getting started to get to the point where we can start coding kept getting pushed further and further back. Yes, Josh? So now we work for 8 hours so we can code for 1. Okay, I got a code. Oh. Huh. And you guys could also see the code. I don't think that matters, though.
Is it one-time use?
Yes? Okay, let's resend the code.
Someone said, what's your education background? And someone else said, what are the factors that push back coding?
Okay, so for instance, today, in order to actually start working on this, we had to go move an air hockey table out from Josh's... Do you want to pick up the camera and point it at this area? We had to move an air hockey table out of Josh's basement in order to get an area big enough to work with the Vive. And the whole Vive thing, we're having a really big problem in this environment. It's like we're getting reflections, but we can't tell what from. So we were sitting around for until 2 a.m. last night with blankets covering up random things, trying to improve it. Whereas I'm just not used to it, man. It used to just be in college, you just go code things and you just go do the thing you wanted to do. And it's life is just... I don't know, maybe that's just a factor of getting older. Or, as Christine pointed out earlier, maybe it's just a factor of doing more complicated things. Okay, issues. New issue. Wait, why is there a pull request? 6 hours ago. Sweet, I want to see that. Oh my gosh! There's a lot of stuff here.
Someone says, can't you record it with a camera that supports night vision so you can see where reflections are coming from?
I left my infrared camera at home.
Mounting the lighthouses on the ceiling seemed to help.
Wait, what did he delete from LinMath? Oh, that's fine. That can go away. I don't need any of that stuff. Oh yeah, mounting them on the ceiling helped, but it's still there. It's just not great. What was I doing? Oh, that's right. GitHub, CNLore, LibSurvive, issues, new issue, identify minimal hardware that will be able to...
Someone that got on wants to know what you're doing.
Wasting time.
And if you guys in chat want to mention off any other boards that you're pretty sure can drive the Vive, let me know, and I'll add them to this list. Or better yet, go like add to this ticket anything that you guys can find. If you guys don't mind in chat who were able to give me some of the information about the pixel clocks and stuff like that, you can add that information to LibSurvive ticket number 35. We're gonna have to move on now, aren't we?
Mm-hmm.
So what are we gonna do? Are we gonna switch to my laptop, or are you gonna code on your thing, or what are we doing?
I don't know. We never came up with a plan.
Yeah, we didn't come up with a plan. So what we're gonna be doing is coming up with a plan. A lot of things were done. I know, like, I'm familiar with everything I wanted to work on. Did you want to try to? I don't know what you would do as far as.
Well, the config seems to be working, I guess. Actually, I never actually checked to see if it could write a config file because it was crashing because I didn't have a Vive.
Okay. So go.
Is it config.json? Is that in your directory?
Calibrate. Can you plug me into the USB on Vive?
I thought it was. Yeah.
Oh, I'm plugged in? Oh, hey, I got stuff. Okay. Let me also remove the star. Well, that looks really bad. Why does that look so bad?
The font smoothing. So the hinting is not correct.
Let's also bring up chat so it's kind of like down there.
You can pop it out.
Good call. I'll pop out the chat.
And then you can close YouTube if you want, I think.
I don't really need to close it.
Okay.
Yeah, I actually am on a mouse now. It feels very strange. Actually, maybe I will close YouTube. It uses less power. DOS EGA 17? No. Let's just use
That was good.
monospace, yeah. Oh, yes. That looks really clear for me. Is that clear for you guys?
Get the chat window down there.
Well, then they can't see. Oh.
Well, they don't need to see the chat.
Well, no, we want to actually be broadcasting the chat.
No.
Because, hey, Christoph. Yeah, data looks great. Okay. It's collecting that data. Everything's fine. So the one thing I really wanted to do was I wanted to try to bring David's... Okay, so first of all, I wanted to try to make a poser from the lighthouse solve thing that I did in order to try to find the lighthouses. And then I wanted to go pull that data back into figuring out where the object is based on the lighthouse, and then find it. I don't know if Ben's still in chat, but there was a funny thing that happened when we were at the cabin. I think it was live stream 3, where Alan Yates was like, okay, now figure it out for one lighthouse. And I'm like, why would I figure it out for one lighthouse? I want to be able to triangulate between the two lighthouses. And then finally just now...
Not a good idea.
Not a good idea. It took, I don't know how many months to finally realize, like, oh, the right answer is you just figure out the right pose from each lighthouse, and then you use that to resolve the position. So you guys were right the whole time. I'm hoping Ben sees that. But yeah, it's kind of embarrassing when you were trying to chase after something for that long until you realize, like, oh, it's not going to work. But at least there wasn't that much effort that was wasted on it. Let's see here. So, poser dummy? Yeah, let's do that. I'll write that in there. Okay, so for you, I don't have the configuration file, though.
I think it only writes when it closes.
How does it close?
When you close it correctly.
How? What button?
Whatever it calls... it happens right before it frees all the resources at the end of the program.
But I don't have a button to do that.
You don't just close the window?
If I close the window, doesn't it kill it?
It shouldn't.
let's see if it kills it. That's an interesting question.
I mean, I figured it wasn't writing it just because it was crashing.
So Ben, are you giggling that you guys knew the entire time that the best way to do this was to find the pose with respect to each lighthouse and then figure out where you are relative to that, rather than to try to triangulate between the lighthouses? No, we still need to figure out the positions of the lighthouses, but the way in which you actually solve the problem is totally different than I had been planning on. Okay, so I'm going to just printf down here. Oh, we never even close it. Yeah.
Well, where did I put all the stuff?
I don't know. Where did you put the stuff?
Oh, when you destroy the instance of survive, when you destroy the CTX, which never happens.
So I'm guessing you developed your entire algorithm around the idea of having one, and then you have two, and you're like, oh my gosh, cool, now we can get even a better idea as to where everything is. Yeah, ESP32s are pretty sweet. I'm still pretty much stuck in C land, though, because I'm Charles, and I don't really like Arduino. But that's just me. So I don't know, where does it... Is there a way I can force it?
Force it to what?
Output? Like some function I can call to make it output?
Yeah, you can do it's config underscore write or save or something like that.
So if I say C wrong button.
Survive config.h.
Got it. We're in here. What is it? Survive.
Yeah.
Where do I get the survive context?
See, that's your CTX.
Okay, so let's see here. Maybe there should be like a Q button I can press, I guess. Or it should like quit.
Well, how does it run it to the end of main?
I think it actually waits until there's a problem with it running. Let's take a look. First of all, let's just see if you actually do that anywhere.
Yeah, I do. It's in
It's in survive.c, okay. Config save. Oh, okay. So this is in survive close. Okay, so we should probably make this a Q button.
for quit.
Mm-hmm.
I thought this happened when you closed the window. Which it probably should.
It probably should, but and quit 0. And not quit. Then survive close CTX. That should do me, right?
Untested routine will crash.
Now let's just say Q. Let's see, did it output the file?
I'm guessing it's going to be empty. Yeah, it's right there.
Config.json. Okay, that's a reasonable file. Hey, thanks, Eli. Or that's Eli. Can you write that into the config issue or the HTC 5 issue thing? Oh, 250 megahertz is still too slow. Wah, wah. 297 is what we need. So I saw at some point it was like outputting a bunch of junk. How do I make it do that?
You have to let it run the OTX decoder and populate the lighthouse.
Okay, let's do that. So I'm going to say O to turn that on. Do you want to turn on the... You just have to turn on both watchmen and make sure there's, at least right now, make sure there's a point on the watchman that's common between both lighthouses. You're probably best putting one on, like... Well... No, it's still not getting it. Try moving one of them. Rotate it around a little bit. It's got to have a point that... Hey, it got one. Okay, let go. Okay, now it's collecting the data.
Is that going to change the way that works?
Yeah, that's all going to change because we no longer need a common point in order to do the calibration because it's just going to change. We're just going to do it a different way now. I've never read the book Learning C the Hard Way. I don't know. FPGA for what? Why would you need an FPGA if you have C? I'm being facetious. FPGAs are a perfectly cromulent solution.
Default poser is the name of the configuration value.
What? I've never seen that. Something must be wrong.
Ceiling mount your lighthouses.
I don't understand. I've never seen this. It says that it's accurate to within... What's a micrometer? Let's see. Is it actually? It is micro. 10 minus 6. No, how? My poser claims to that it can... Well, okay, normally my poser comes to like 3 millimeters, but...
You had some Quaternion errors or something earlier.
Did I? Are they quaternion errors? Where?
No, you had it all screwed up.
You're right! So, there's a really funny thing here. Earlier this week, I was working through...
Anyway, write that all back out.
Oh, yeah, I should. Q?
Yeah.
Let's just check that. Okay, so for the longest time, so for months now, we had been trying to figure out, like, oh, it's just not right. It's so close, but something's wrong, and what's wrong, we don't know. It's never able to resolve that well, and I could not figure out for the life of me why my lighthouse poser was just not cutting it, because it should be just mind-bogglingly good.
Want a soda?
Yeah, I love a soda. And here, let me show you a commit.
You want ice?
No.
They're not cold.
Oh, yes, ice then. There is an absolutely hilarious event that happened. It is... How do I... Actually, you know what I'll do? I'll blame the file. That works, right? So, what the crazy thing was in linmath.c, surely there's a blame button here. Blame! In linmath.c, I had a function, and it was... you guys are going to laugh at me. Right here, quat inverse magnitude. So what this is used for is determining the inverse magnitude of a quaternion, because you can calculate that and then you can multiply component-wise by the parts of a quaternion, and it normalizes the quaternion. The problem was that I wasn't taking the square root. So, like, the quaternions were just, like, noodling around everywhere out in space, and somehow this, like, kind of sort of worked. But it actually, like, I've never run the poser with this, and it's perfect. It's perfect. Oh my gosh. Let's see what information I get with that. Do I get... Oh. Let's look at the... I've never seen this before. Voxel test. That's not what I expected to see. expected to see. I don't know what's going on here. I really don't know what's going on here.
What is this?
I loaded the density map. I think this is wrong. I think it's not accurate within 6 micrometers.
It's just broken.
I think it's just broken. I was so excited for a moment there. You know, nobody can see you.
That's fine.
Yeah, that's just all super wrong. I don't even know what that means. Yeah, okay, fine, I was jumping to conclusions. What? How? Do I have any other data maybe? Point info. Nope, that's wrong. Let's try opening it up this way. Space. I mean, all the standard of error looks spectacular. I can't believe that would... Okay, so just so you guys know, what's going on here is when you run the calibrate script, it outputs the sensor number and which lighthouse and sweep number it is, and then it tells you the number of points that it had, and then it gives you an angle. And this angle, no, this is the angle. It tells you the angle from, nope, this is the angle. It tells you the angle from offset from center of what the offset is. So, Typo and default does not really matter. What typo?
Right in the config file?
Where's that? Over here?
Yeah.
Where?
Right there.
DEF.
No, it doesn't matter. Because that's what the program thinks it is.
Well, I'm going to fix that right now. So let's fix that. So that's in... D-E-F-A-U-L-T. D-E-F-A-U-L-T poser. Okay, so that's the default poser. So right now I think the first step would be... So you've already done everything that you need to do there. So what would you do? I didn't think about tasking that well, because we were also completely preoccupied with trying to get him functional and trying to worry about getting a monitor.
Well, first we spent the first few hours figuring out what was going on with the Vive in general in this room.
Yeah, that was pretty bad. Actually, can we check something else? Let's see, what does it think the lighthouse... Oh, it didn't even write pose information.
I don't think I've ever seen it do that. I'm saying I've never seen it write pose information that are not zeros.
Okay, so maybe we should see how that code works.
I just figured it wasn't done.
Maybe it's not done. So in here, this runs all the code that... I wonder if there is... I feel like I should probably print out the values of everything and then run it against the data again to see how good the results are. Okay, so the point is, you're right, I'm not actually writing out pose data right now. Oh, if print, P-R-I-N-T. Why would I name a variable print? It makes searching for it very hard. Run opti. See, this is for each lighthouse, right? Lighthouse 0 through 2. I'm not waving at you, Internet. Let's see what happens if we run this. Oh, let's let it run. We're going to collect some data. Also, that is a really bad position for the Vive. You want to take a camera and point it at it, see if they can see how terrible that is?
Yeah, I should fix that.
Don't move it though. You have to get closer. You can't really see what's going on. You also might want to show them where all of the lighthouses are. Bend it down more. There, now it's visible. So it's just pointing forward up at that lighthouse up there.
Can you see that?
Yeah, you can definitely see the lighthouse.
We put the lighthouses on the ceiling. We had issues with reflections off of the wall.
Okay.
Is that?
I don't know what I'm looking at. It has a number that's really low, but I don't know what it means.
Where's that?
This is what it output. Oh, it's stuck. Okay,
What did it print out? I didn't see it.
hold on, let me see if I can. Oh, that's the wrong thing. Survive cal LH find. I printed this out, which is, let's see, what do those mean? First one is dist, which is itty bitty. It's a how to basic vid on how to cook. Yeah, he's right. The camera did kind of see the infrared, but it wasn't like, if you look at the beams with a really good infrared camera, it's like bright light blasting in the scene. So that's definitely what we need in order to tell what's going on. Okay, so that's really small. That's dist P. I've forgotten how this code works. Let's see.
Bouncing red line.
Josh just made a joke. In college, we needed to determine the pitch of something, and I stayed up really late, and when we were done, when I was done, I had a piece of code that could tell the frequency of something, and it was written in Visual Basic, and it had a little line that bounced up and down, and it told us the pitch, but we don't know why it works.
And somehow it would curve around peaks that weren't correct.
Okay, so us to target, HMD points, lighthouse POS. Could the owner of the computer in the bottom left tell us a little about it? No. Go watch the YouTube video on it. That is not for today. I guess I could light it up some, though. Oh. I mistyped it anyway. I mistyped it again. Doop. Oh, it's attached up to the wrong thing. Oh, I'm not allowed to write to it. Okay. Okay. Let's close that now. Back to this. So I take the ray lighthouse quad ray shootout. So lighthouse quad is our current estimation. Oh, okay. So what this code here does is it takes a ray shootout. So up here,
It's rotating array by the clock.
right. So right here, this code right here creates a vector. Yeah, it creates a normalized vector, pretending that you are inside the lighthouse and you're shooting a ray out at whatever angle that it actually shot out. So if it says that you are shooting out at like 2 degrees this way and 5 degrees that way, it creates a vector in 3D space of that. Then it rotates the lighthouse around to wherever that would be, and then it offsets it by wherever it thinks the lighthouse is. And then it takes that line and it finds the distance between that line and the point that it should be hitting on the HMD. And then it tells us the cross product of that, which tells us the distance between, it's like a line point difference calculation. Actually, it says right there in the comment, point line distance, line defined by lighthouse pass and direction, ray shootout. And then it tells us how far off from that line it is. And that's insane. Is that actually the square root? Let's Google that. Wolfram point line distance. What does it say here? It says a bunch of crazy stuff. I don't know how to do this math. One of these is something useful. Cross 3D.
What was that code?
It's a cross product. There's a cross product somewhere in here, I think, right? No, 3D.
That's an X.
Josh just pointed at an X. Here we go, 3D. Ooh, here's a cross product.
See, they use the X. It's right there.
Yes, Josh is correct. There is an X right there. Okay, so let's see here. So cross product of us to target and the ray shootout. I think it's the magnitude in 3D. So that's the error squared. Let's not look at the squared error. Let's just look at the regular error. Oh, actually, no, we have to do that, otherwise the algorithm will just totally break.
Yeah.
Okay, let's try recompiling that.
No, you need that. You need the error squared.
Why?
I don't remember why.
But magnitude 3D has got to be, it's already going to be a very good value at least. Oh, I just realized that would be the square root of 6 micrometers, which is like bigger.
What? The square would be bigger.
No, the square root would be bigger. Yeah, it's 2 millimeters. Because the number was squared. Boink. Boink. That's pretty good. 1.9 millimeters. That's not bad.
I'm still trying to figure out what's going on with that voxel volcano.
Yeah, I should probably try to figure out a little bit more about what's going on with the voxel volcano. What is going on with the voxel volcano? That was modified 3 minutes ago, or 6 minutes ago. Oh boy. Yeah, that's just wrong.
That's weird. Oh, it's only pointing at one lighthouse.
Let's get that fixed first.
Alright, that might work.
Okay, let's run this and hopefully this will work well. That's really good cola. Is that actually the off-brand cola?
Yeah. I don't buy name brand stuff. Unless it's computer hardware.
No, clearly not, because
No,
none of your stuff works.
It's that laptop's like 7 years old.
So right now I'm trying to figure out if my pose finder, which is a really slow pose find, like super slow, it takes like 2 seconds to pose find, is suitable. Ooh, 9 and 10. That looks pretty good. Okay, I'm okay with this. Oh wait, if it's the magnitude, is it really the magnitude squared?
Internal combustion laptop. Yes, it is.
Okay, let's take a look at this data now. No, that makes no sense.
When was the last time this worked?
I don't know. But I don't want to start going back and looking through version history. That's really weird. That means it wasn't able to find the distance either. Do you have a 5 meters? No, that can't be right.
That's not right. I do have a measuring tape. You want it?
Yeah, let's find out what the actual distance is. So apparently in... Wait, maybe I'm supposed to be... plot set...
Sound like a Castro?
Plot rotate vector.
Or these, there are these motion or
I also used to be normalizing the quaternion in here. But I should probably do that beforehand now.
Alright. It is 9.5 feet.
Oh, you know what? There's multiple times this has to get done.
This one is going to be a bit further away. Charles, you want to grab the end of this?
Wait, where am I setting that, Ben? Actually, can I? Hold on. I know very well 1111 is not an identity quaternion. For us, the identity quaternion is 1000. And
12 feet 7 inches.
okay.
So 9.5 and
1, 2, 12.5. So 3.8, and what did you see the other one was? 9? 9.5, right?
yeah.
Okay, so it'd be 44 divided by 39, and 9.5 divided, or times 12 divided by 39, 2.92. Okay, so now we have at least some basic truth. Found it in the source. I don't... Oh my gosh. Oh my gosh. Oh! That's not the identity. That's just a random one. It won't affect any... It might affect something. I'll be... let's just mess that up. Anyway, I still have to normalize. Thank you, Ben. Gotta normalize.
No, we did all this for Mercury too.
Yeah, we did, and apparently Mercury 2 also had that bug, by the way.
Bug.
The bug where I didn't have the magnitude figured out right or whatever.
Oh. Maybe that's why bone animations were wonky.
That is almost certainly why bone animations in that game engine were wonky. I can't, what is that? That's been like 5 years?
Longer than that.
There was a bug in a library file for a very, very long time. Quat, normalize, concat quat. Sounds like a fruit. And we need to normalize. I'm going to put these somewhere else. I'll hide them off screen so you guys don't have to deal with it. Okay, let's run this now. Okay, it is going.
That's weird.
What? We actually don't use matrices here right now. We're using mostly quaternions. That's just because they're easier to do math with, even though matrices are faster when you get to the end. Like if you have a matrix and you need to rotate a point by it, that's faster if you have a quat and you need to rotate by it. You're right, I do need to kumquat. Let's see. Oh, that's sad. Maybe it does need to be squared.
I'm pretty sure it does.
I'm thinking that those changes to the quaternion library have caused bigger problems.
Are the changes correct?
Oh, did good things when I tested them. Here, I'll show you guys what I did. So in the quaternion library now, redist, then test.c. What I do is I take an arbitrarily Euler rotation, and I generate a quaternion from that Euler rotation, and then I convert that to a matrix, and then I generate a quaternion from the matrix, and then I convert it into an Euler vector. And then I create a point, and I rotate that point by the quaternion vector. Then, by the way, it's really neat and easy to flip around a quaternion. You just flip around the first point, and then I rotate that point back by that quaternion, and I somehow get the right answer. So I'm thinking all of those operations in between are probably pretty good. But maybe something else is going on. Let's see. What did the? That's pretty good. That's reasonable. Now let's see. What does the Voxotron tell us? Voxeltastic, sorry. That looks more like it. Yeah. Yeah, that looks more like it. Okay. So my thing may be bad, but whatever. Let's see what the results are. 3.8 meters. It's supposed to be 3.69. And 2.9 meters, 9.2. That's close 6-ish. I don't know, within a decimeter. Hey Ben, just wondering, how close should we be able to tell how far the lighthouses are to where they really are? Ah. Okay, and there's actually something we're going to be changing here. This is going to go away, and all of this is going to get turned into a poser. So the posing system is a new system.
You haven't changed all 1 to 0. Is it okay?
No, so what I actually wanted to do, what Ben Jackson pointed out, was that in the quaternion I had written 1, 1, 1, 1. And now I'm actually really curious if that guess changes the behavior. And the problem is that 1, 1, 1, 1 quaternion is not a valid... you can't measure how far are you from you really are. You can measure how far your solution is from minimizing some error function. No, I can measure how far the lighthouse is from, because we just, oh, you missed that. We took a tape measure and measured the distance between the headset and the lighthouse. And it's not right. The actual distances are 2.92 meters and 3.69 meters. At any rate, Diastark, this is not a valid quaternion. A quaternion that's an identity quaternion that doesn't do any rotation is a 1, 0, 0, 0 quaternion, or I guess even a 0, 0, 0, 1 quaternion, or I guess there's a bunch of quaternions that would be identity quaternions, but...
Does it depend on what you're using it for?
I don't think so. Actually, now I'm thinking about it, why would a 1, 1 or 1, 0, 0, 0 quaternion be? Let me Google that. That might not be right. That could be a bug in the library too. Let's see, what does MSDN believe quaternion identities are? Okay, right.
0, 0.
Right, but is their definition for quaternion the same as mine, I wonder?
Are there terms in the same order?
Okay, good. Well, no, because if W is 0, it doesn't matter if you have like an X of 1. I think all that matters is that... Yeah, I think... Right, but if W is 0, then you have an identity quaternion no matter what as well, right? So like if W is 0, it can't make any rotation motion. XYZW. So yeah, so at least we now match Microsoft. I don't believe you. I'm going to test.
Oh God.
Let's create a new quaternion. Not that I have any reason not to believe you. Zero, 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 -1. Huh. Well, I just learned something new.
Listen to Ben.
Listen to Ben. Nope, it's still wrong. Why is that wrong?
Because your plot rotate vector really handle the output aliasing the input?
I'm not sure. Oh yeah, I forgot to recompile. 0001. Yeah, that's right.
Ben's question.
Output aliasing the input. Oh, you mean like? Well, I can fix that. I can say 111. That should be fine then. Yeah, that does flip it. My understanding of quaternions is not what I thought it was. Oh, you learn something new every day. Can the output be the same as the input? I don't see why.
PT.
Oh, yeah. That's fine. That's fine. It totally can do that. If I rotate the vector, it actually copies it anyway. So the input can be the same as the output. It's just fine. Okay. Back to work. Work.
What should I do?
I don't know.
Okay.
I was hoping you would have the Vive running on your thing.
Yeah, it doesn't work.
Oh my gosh, people are writing in there all over the place. Great.
So we need like 300 megahertz.
Yeah,
right?
we need like 297 megahertz. Come on, guys. Somebody's got to make a board that can do this.
It's called a G-force.
Ben, I definitely think that that is the same way a lot of the people on the Wikipedia page for it think about it. Whoa, that is all kind of messed up.
What is that?
That's the probability cloud for where the other lighthouse could be.
Which lighthouse is that? We're not sure.
Lighthouse number 1, whatever that is.
Want me to cover it? Or
No. Wait, was that 1 or 0? I can't remember. Which one did we just load? That's 1. So that would be C. It's the one that says C.
that one's screwed up. This one over here.
Do you want to cover that just to see if that actually is it?
Well, it doesn't work if you cover it with LibSurvive.
That's a really good point. I have an idea. Let's move it really close to one of the lighthouses.
Alright. Move really close to which one?
Move really close to that one.
Okay.
Oh hey, David Chapman came up with a really good. So I want to get my poser working for the calibrate, but David Chapman came up with a poser that can pose a system, even though it's not perfect, but it can pose in about 1.6 microseconds. That's micro with a little u, not like little us. And so I really want to try to get that in today. So anyway, we got to rerun that. David, by the way, it's Dr. David Chapman. Sorry. There's so much stuff that's going on, and the technology is getting so ahead of us right now, and we don't even have a second monitor. So we're trying to figure out what Josh could do. I don't want to. Ben is saying a lot of very interesting things, but I want to.
Are the live chats savable?
No, the live chats are not savable, but we remembered to have it up on screen so you can always see it. I encourage people to read the things that Ben is saying. Okay. It is. That's Lighthouse 1. So you think that's C?
That's C.
Okay, let's take a look and see what the data is coming off of it as. Yeah, that's really weird. Why is that so bad?
Is this a LibSurvive problem, or is this a my reflective wall paint problem?
I'm not sure. You know what we need to do?
Can somebody else run this on their setup
They
in a place that
could.
works?
Actually, that's a really good point. Does anybody else out there in the live stream have access to a setup with a Vive and LibSurvive, so you can just run this against it and see if you're getting this really weird data? That would be really, really nice and helpful. If you guys can just, if anybody else can run this, I would really appreciate it.
Do you want to try your headset, or is it?
Actually, yeah, do this on my headset. We'll get another Vive out just in case. Actually, interesting thing, Josh is going to be buying this unless we find something disastrously wrong with it. I've already paid my coworker for a second Vive to sell to Josh, so fingers crossed it's just fine. And it's something about his basement.
Where's the thing?
What thing?
The box that it plugs into.
In the little blue box up top.
Oh, okay.
Yeah. Okay, so first things first, what we actually have to do now is we actually have to convert Dave's code, or sorry, not Dave's code, my code, into a poser. So,
So we're going to plug into my laptop.
poser slow Charles.
Run a calibration routine on it. Huh?
I'm not going to accept anything from the IMU. I'm not going to accept anything from the light, but I will accept full scene data.
Just can't put it in the screen.
So I can go hopefully copy and paste this pretty much wholesale.
Right. But that's a limitation of my computer.
What are you gonna do?
Use my one upstairs.
So why don't you do that now?
We don't have a
That's
monitor.
screen.
Oh, that goes back to the monitor.
Josh, is there seriously nobody you can text to get another monitor?
Nope.
Is there a Best Buy nearby?
There's one right across the street.
Oh man!
I was thinking about making this
BestBuy.com. Let's just see how much a monitor is. We might just go buy a monitor.
Charles,
Huh?
do you like meatballs?
I don't want that in the video.
You can have it in the video.
You can say no. I have like 6 different
I
options.
love meatballs, but you have to make sure that the sauce doesn't have vinegar.
Oh, so I'll look at that pretty good.
Yeah. And make sure that the vinegar, like the meatballs aren't, like if you make them yourself, it's fine, but if you get them made.
Okay.
Well, I have like 6 different options, so let's go through them.
Yeah, no, we're not going to be getting, we need a cheap as possible monitor. We just need something for Josh to use with his
Of course,
thing.
you know what happened. I get the monitor and my radio wouldn't really probably work.
They have a $49.99. Oh no, I need to select. Wait, store pickup, Lexington Park. Oh, that's. I need it in stock in Lexington Park.
Wait.
Is it not Lexington Park? Is there another one closer?
No, there's only one.
It is the Lexington Park one.
Yeah.
How do I tell Best Buy that I want it? Which ones are in stock? In stock.
That was no more idea.
Pick up today. $59.99. What is it?
I don't care that much.
I might buy it, so I have a monitor. 1600 by 900? Yeah, no, forget this. Are you okay with not having a monitor for
I
this?
don't care.
Okay. Okay. So, in here, poser, slow Charles,
Power supply. Is this it? Yes, this is it. Right?
Yes, that's it.
And this is the wire I use, this little short one.
Yeah, I'm gonna go make it so you can see what you're doing too in the.
There is one plug left on the power strip. This power strip.
Nobody's a fire marshal, right? Okay, so poser full scene data.
Are your changes committed?
Let me make sure. No. Everything looks fine though.
Is citric acid vinegar?
No. If it's citric acid, I'm set.
Okay, I think the sauce is fine then.
Okay.
And the meatballs didn't have anything that sounded like vinegar.
Okay. The one I can't have is acetic acid.
Okay. Okay.
Wait, which live stream is this? This is number 8?
9?
No,
8.
can't be 9. 8? Do I say in the title? What live stream number is this, guys? Whatever. From the current live stream. It's 8. Okay. Okay, now it's pushed. Go for it.
Did you calibrate?
Mm-hmm.
Oh, we're gonna plug it in. That would help. Oh, collecting data. So, does it need the watchman? And how does the watchman know what vibe to bind to?
I didn't bring my watchman. Tell you what, you don't actually need that check. Can you edit it so that it doesn't do the check? It's like a src slash survive cal.c.
Right. Where am I going?
src slash survive cal.c.
And what am I looking for?
If that matters. I think I even commented. It's like common theme for something.
Stage 3 could not find suitable common point on watchman.
Yeah, make it so that can't happen.
So,
Just plow through it.
just comment out that check.
I guess if that's what's stopping it.
Well, that's what will stop it eventually. I
Just-
just want to skip it altogether.
You need it to get to stage 4.
Going through data, make sure we still have a sensor on a watchman. That comment's not even complete. Oh, whatever.
Yeah, just try to get it to plow forward.
We don't need that. Useless code.
Well, that's weird. If I click here, the underscores disappear.
What?
Whatever, they're still there.
So how long is it going to loop through the searching for common watchman?
It shouldn't. 5 times. It does do it 5 times, but it should say good or something.
It just says it's, counting up to 32 and then it's 0 to 5.
Oh, yeah, you're gonna have to make it so it'll advance. I don't.
Alright. I'll put this thing as a stick.
Okay. I don't know what to do there, but I know that it can be done. Oh, I know what I was doing. Survive cal.h. Because right now it uses cal data. That thing right there, and that's not what I
handle
want to do.
count, no, that means all that stuff.
So it's not that. It's going to be...
No, this is not what it is. Searching for common. Determine if there is a sensor on a watchman visible to both lighthouses. That looks like the right spot. We'll just comment it all out.
Okay, replaced all that.
Stage 2 good, counting. Stage 2 bad, what are we doing?
I just realized I pasted this in the wrong file.
That's not good.
What?
What if I just set it to stage 3?
Maybe that would work. I've forgotten which way the stages go for the calibration. Survive cal data. It's turned into this thing here. Is all. Okay, so and whenever we see average sweeps, it should become angles.
Great, searching for common watchman cal. We want to skip that too. Right?
Say it again.
We want to skip stage 3 also.
Yes, but there's some stage that you have to collect 1024 data points, and you want that one.
That one has not happened yet.
Okay.
Well, what do I do now?
Could not load driver. Whoa. Could not claim interface. Am I running it? Oh, I'm still running it. Okay, so that's fine. Just realized it didn't even build the file, so that's not going to do anything. Posers, source/survive cal, no. Source/poser slow.
Wait. Huh.
Actually, we should probably just roll this in with LibSurvive core. Hello, compile errors. This is what I was expecting. Slowcharles.c line 5. Okay.
So Charles.C line 10.
You know, I'm just going to tell it found a common point. Like right off the bat.
Yeah, thanks Octavio. That was a typo. Line 45. It should take a. Oh, whoops.
Okay, that's working. Wait, what?
Line 91. That's the difference. That's.
Alright, where do I go to use the voxel thing?
Voxeltastic. Google Voxeltastic.
Is that your thing?
Yep. It's like a GitHub IO page or something.
Okay. Voxel-tastic.
If yours looks interesting, I would be up for
Yeah, I'll send you the file.
VNCing. Oh no, I was gonna say VNC.
Yeah, I
Just-
guess I could do VNC.
Yeah, if you give me your IP or whatever. Run optimizer. So how does that work?
Where's the files?
What?
Where are the files saved?
In CalInfo.
There's nothing there.
Did it succeed?
Yeah,
Look in your CalInfo folder.
it was there. No, it's not. There's nothing on the screen.
What do you mean?
There's no voxels.
Oh. Check and see if WebGL is running for you. Could be up to date.
No, it did its thing when I went to the page, right? It did that.
Ah, okay. Oh, click on the load.
I did that.
Well, let me see it. You have to type in 32 or 64, 64, 32, and then you can load it.
So that just tells it,
The size of what it's expecting.
okay. 64, 64, 32.
Mm-hmm. So this poser function, we're gonna have to work on the way that works.
This is weird.
Let's change that to it. Lighthouse ID.
This is really weird.
I'll take a look in a second. Actually, tell you what, let me pull it up here and then I can just look at it without bending over. What's your whatever it is?
Yeah, hold on. Let me start up VNC.
Okay.
You actually should be able to get it to work in Windows. What exactly was missing? I can't remember all the details. Oh, you know what we should probably do? We should probably include OS generic as part of the core build so we don't end up using things like usleep and junk like that. Yeah, the JJ11 or 1010, if you can, see what's causing Windows to need unistd.h. Just comment out unistd.h and see if it goes.
Are they compiling it for Windows?
Yeah.
Cool.
Thank you for compiling it for Windows. It is necessary step in sadness.
No, it's perfectly acceptable.
No, I don't want it to do by Lighthouse ID, actually. Don't want that.
My IP address is 191.
Well, I don't know the rest of the network. 192, 168.
191.
Okay. Ooh. How am I gonna scale this? Because your screen is way bigger than mine is.
Alright, well,
That is super hosed. Can't.
hold on. I'll scale it down.
Okay, I'm gonna close it for right now.
Yeah, until I get it right.
Yeah.
Yeah, thanks. Because
What? Oh, was I taking control of your mouse?
no, I had my email open, which is no longer open.
Oh, okay. WSL won't do USB. That's a good point. So, Live USB in Windows requires you to have an you can kind of get away with it. You can use Live USB to generate a
Okay,
fake
Josh,
driver in order to
guide
make
me
it
on the
go.
sizing.
Say what?
Guide me over the size.
It has to be, make it less than 720 by 4 or 1280 by 720. Make it less than 1280.
Make what less than 1280?
The width of the screen.
It doesn't tell me how wide the window is.
What do you mean?
What do you mean, what do I mean?
Are you going to change your resolution?
No.
What am I supposed to do?
Just switch back to the ANC.
It says failed to connect to server.
You were connected before, right?
I was 192.168.1. I used the up arrow to select. Oh, hey, it's in. Okay, so what? Oh, I see. You want to keep the same. I can't move your window.
Okay.
Okay, whatever. This is probably fine. Try changing your. Ooh, can I take control?
No, I have a view only.
Oh, okay. I would set the clear to 220 and the opaque to 255.
Wait until you see the other file.
Okay, maybe make the opaque 240. Okay, that's not that bad. Again, this is with Charles Poser, which is pretty bad. And soon we're going to be able to use Dave Chapman's Ortho Solver. Whoa! That looks great. Which one is that?
Lighthouse B. 0.
Wow!
Maybe I should move that light out of the way.
Oh, yeah, it's also kind of pointed towards Lighthouse B.
Yeah, thing.
Oh yeah, but that's, yeah, you want to narrow it down and tighten it up more though.
So it's really just that blue area.
Yeah, you don't really care about when it's like a pretty awful answer. Yeah. Look at that data. Oh. Yeah. You're a little Gaussian blob, aren't you? Okay. Oh yeah, Windows subsystem for Linux. Yeah, I don't know what to tell you guys. If anybody can figure out how to get like live USB working on this for Windows, that would be super swanky. I'm gonna move you off to the right, Josh.
Okay. I'm going to cut your connection.
Okay.
Alright, you want me to run it again with the light moved?
Uh-huh. So I need to, in here, my code, position set, wait, is that really CTX? Oh no, CTX is just straight up available.
So if I put them right next to each other, should the results be similar?
I think so. The big thing is the angle has to be exactly the same. You're out of view. Do you want to... I'll rotate the camera.
Yeah, of course.
Okay.
So now we have two Vives sitting next to each other on the floor. So you're gonna run it. I'll run it.
I just finished running this one.
Oops.
I'll run it again.
Uh-oh. How's this gonna work? I already removed that from my build. Hopefully I didn't break two, boy.
You can stash your current Git stuff and then just recompile. Git stash. Git stash.
No, give me a minute. I want to blow it away.
Just Git stash it.
I don't want to stash it. I want to blow it away. Yeah, there's no... The diff isn't even there anyway.
Alright, well, I
What
ran
is
it
it
again.
complaining about?
That's weird.
Oh, whoops. Okay, now I'm going. Mine is running. Can I bring up yours so we can watch them run at the same time?
Yeah, hold on a second.
Okay.
Sure, you can bring mine up.
I don't know what causes the distribution in my thing, but I'm pretty sure you're gonna have to press O, right?
Yeah.
Four centimeters and 5 centimeters. That's probably fine. Okay, that's not that bad. It's not good, but it's not that bad.
Alright.
That's pretty terrible. That's very terrible. What in the world? Okay, so which lighthouse is that one in yours?
Which one do you want me to load?
Let's load 0.
0, I don't get any data. Maybe I need to zoom out. I don't have any data for 0.
I'll bet you have the data. I bet you just have to... can you shrink your window significantly? I think you have to start clear at 0. Okay, bump it up some.
Yeah, that's weird.
Yeah, look at them. They actually are pretty similar, though.
What do you have your number set to?
240 and 180.
Oh.
I just made mine match yours, though. That's interesting that they are different. Let's load 1. Wow, mine is all
Mine's
kind of wrong.
trash.
Yeah. Which one is Lighthouse 1 again?
I think it's this one over here. Oh, that one over there.
Huh.
You know, there's not a whole lot of sensors visible to that lighthouse. Well, I guess if they're both trash, then whatever.
That is concerning. I hope that lighthouse is okay.
Huh.
You have to worry about if it,
Up your restriction. Make it like 200 and 250.
I don't know
That's
what you meant.
really wrong, though. 250 and 200, sorry. That's just absolutely wrong. Because the angle on that would have to be pretty steep. It should be very shallow, or very low. What is up with that? You know what? I just realized we can run David Chapman's OrthoSolve on this. Let me go try to do that. Hey, David, Dr. Chapman, are you still in chat? Should be able to copy HMD points and PT info and HMD normals into Dave here. Oh gosh, how do I interpret Dave's data? Hi, David. Wait, Lagrange multipliers. Okay. I don't know. I think I have it now. I just couldn't figure out how to. I forgot how to run your thing against existing data. So let me try to graph this again. Hey, that looks interesting. Not great, but pretty good.
What does that mean?
That's nice. That's one of the lighthouses from Dave's point of view. Let's run Dave's thing with the other lighthouse. The problem is if I broadcast the whole desktop, then the screen resolution is much higher. So it makes it hard, and it also uses up more bandwidth. So make and affine solve, and oh my gosh, that's a lot of points visible.
That must be Lighthouse B then.
So that's lighthouse 0, so that would be B. B would be the one with the ton visible, according to this.
Yeah.
So yeah, B is 1, C is 0. Oh boy. Oh, man.
So which lighthouse was that?
Hold on, that's
C?
C. That's B. B looks about as rough. Actually, you know what I can do? Data ranges. G. 12. Oh, wow. So many points visible. I'm getting really close to just dumping my mine altogether, because if his thing comes up with a better answer than mine, then it's just pointless. Scale. Minimum. Huh. It looks reasonable. So what you
It's
guys
in
are
the
seeing?
shape of a headset.
Yeah, it is in the shape of the headset. So what we actually see here is the expected angle. Sorry, the blue dots are the actual positions being received by the headset from where the lighthouse thinks all the angles are, and the the red dots are where David's algorithm thinks they should be based on his matrix for what he thinks is the update, whatever it is, of the lighthouse. So the orientation and pose of the lighthouse.
Can your thing pick up speakerphone? Call Dave.
Actually, David Chapman, do you want to Oh, I am out of battery.
I'll get my phone.
I'm gonna actually plug mine in because.
I need his number from your phone.
Okay.
Without telling everybody.
Yeah.
And
Watch. I'll let you know.
how do I work your phone?
Yeah. Click that button. Click the phone button. Oh, that works too. You can get. Yeah, you're fine. So, David Chapman, where is? Oh, here's your widest. Okay.
Is it just Dave in here?
Yeah. So 3.1 meters and Lighthouse C is 3.58. So let's see in real
Does he
life.
care if we call?
Hey, David Chapman, do you care if we call you and then you could talk live? Actually, we could jack him into the computer.
With what?
A headphone jack? Do you have a headphone jack here?
We have like 40 feet of Vive cable.
Sure.
Like a
Let's see if
headphone
that
jack.
works. That'd be neat. But let's first measure the. Where's the tape measure? Do you have a tape measure?
I think it's on the couch.
On the couch. Nope. Chuck Testa.
What?
I don't know where it is.
I thought I put it on the couch.
I'm looking on the couch. I see no tape measure. Great. You don't even have a way of. Oh, here it is.
Where is this? Oh yeah.
Is Christine free, or is she
I
just?
think she's cooking. Alright, I found a combination of wires.
Let's say that that's about. Okay. I'm gonna go with 11 feet 10 inches.
And this one is. Can you hold that one up?
Feet.
these.
So 3.59. That's pretty close to 3.64. And
Yep. Did Dave answer us?
David Chapman just ran. So David Chapman, can we call you? Oh, he says, sure? I think he said sure.
I'll give him a call.
Okay. He says okay. Okay, we're calling you right now. I'm going to...
Hey! Alright, I'm gonna see if I can plug you into my phone. Alright. You still there?
Hold on. I'm going to just make him the... Why can't I have two audio sources? This is weird. Give me a second, Dave. Audio. Aha. Wait, what? No, what? What? I don't even have... I don't have desktop audio. Well, I don't get it. How do I not have desktop audio?
Well, I can just hold the phone real close to the microphone.
Wait, GM204. There we go. What? Wait, no, that says HDMI. But that's really going to sound bad if it has to go through a second phone. Do you have a USB audio dingus?
Yeah, I do.
Good, let's use that. That might actually work. Sorry, Dave, hold on. Oh, you know, we never ran his code against the other one, or did we?
Yeah, we did. We did both. Take your pick.
So it's off by 3 centimeters and off by 3 centimeters. So I'd say that's pretty good for Z. In fact, I would say that is within our measurement error. So what I'm going to do right now is completely abandon trying to port my code over to this and only worry about porting Dave's code. And for right now, we'll just call it good enough.
These things aren't labeled. Is yours labeled?
Yes, mine is labeled. I need a place I can plug this up. Plug this in over here. Okay, it's that plug right there.
Is it gonna work?
Mm-hmm.
Do you need drivers?
I don't know. Maybe.
I'm plugged in. Let's see if it identified it. Aha! Oh boy, there's a lot of audio connectors. Hey, that might be it. So, settings. Audio. Secondary device. Haha!
Dave, say something.
It says they can hear him. So Dave, I have no way of hearing you, but
Hello?
I think
Can you
the
hear me?
internet has a way of hearing you. So whatever you say, you're live, and I don't know what you're saying.
Oh, really? I haven't said anything yet.
Let me turn you down.
Can anybody on the chat hear me?
No, that's the wrong one. Okay, I think you might be good now. Let me see.
Can anyone hear me?
Ah!
Yeah, we can hear you.
Hold on a second, Dave. Let's see if we can get this going.
I'm gonna turn down my phone.
Alright, that sounds good. I muted my, yeah, I can hear myself on the chat, okay. So,
I also mixer this.
okay, is this better?
5.
How about
now.
this?
C4. Okay, let's see here. I'll plug this into here. David, can you say something? David? It sounds really hard to hear.
All right.
Whoa. It's really
The
loud.
orthographic projection uses an axon metric. The code that I wrote.
No, David, you're going in and out. Hold on.
Orthographic projection.
Hold on, David.
Um,
Oh no, he can't hear us.
You want me to unplug them?
I
No,
can-
whoa. Oh,
well, if I put the microphone,
Do you need me to turn it down low on here?
okay, you're really, it's really watery, David. Okay, you can turn up your microphone. I can turn you down here. Go, David. Turn
okay.
up. Oh, hey, that's pretty good. Okay, again.
Okay.
Okay, almost perfect. Go.
All right. So the code that I wrote, it assumes an orthographic projection or an axonometric projection to solve for pose. So it would be really cool if you brought up a Wikipedia page that talks about the axon.
Whoa. Hold
Because
on.
there are some really funny pictures of some paintings that you can make in those poses. But basically, I'm assuming that the screen space points, the points that you see in the coordinate system of the lighthouse, that those points are some nonlinear function of the points that you have the offsets of the head mount of the head mount device from the center of the device. But then it basically just assumes a linear approximation. And the reason for that is because it's really hard to tell the difference between when an object is getting smaller because of its scaling versus when it's getting smaller because you're moving it far further and further away.
David, let me
So
pull
the
up.
idea that moving an object further away from the camera looks a lot like making it smaller means that we don't really have to tell the difference. What the code does is that it assumes that when it gets smaller, it's because it's scaling, which isn't reasonable, but it just makes that assumption. Then it says, okay, it's scaled by this much. So then how far away from the camera does it have to be? And it turns out that if you want to figure out what the pose is, a lot of times when you have a 2D sheet of paper, what you do is you draw 3 axes.
Hey, David,
X, Y, Z.
can you hold on a second?
Yeah?
Hold on a second. Let me pull up some of this stuff. I found a while back a picture, an animated GIF on YouTube of that I think really helps. It's the picture of the house. Do you remember where that is?
I remember that there was something on Wikipedia, and I forget which Wikipedia page. There was one that went through the difference between a projection where you divide by Z, a linear projection, and some of these axonometric projections.
Aha, I found it.
Okay, you found it?
Yes,
Great.
okay. So what I have
so-
open is the picture of the house where they kind of show what the two different extremes are.
Yeah, so that picture that you see, that you see of the house, really, it shows that there is some difference, particularly when it's really close to the camera. But the further away you move from the camera, the less that difference is. And even though there's some difference, it can still figure out the rotation more or less, even if you assume an orthographic projection. So it's not terrible. But it's basically, the approximation is basically where you say, I have a 2D sheet of paper. I'm going to draw 3 lines that aren't orthogonal. I'm going to call one X, one Y, and one Z. And then I'm going to say, okay, that's what it is. Okay, now move it back in 3D space and figure out how far away it has to be for that to make any sense. So that's basically what it does, and it's really, really, really fast. So, and if it's good enough, then it's good enough. If it's not good enough, then I think, if nothing else, it could be a starting point for an initial guess for an iterative algorithm. A very good initial guess, but it might be good enough. So we'll see. We need to test and some different. I think there were a couple of cases where it didn't pan out with the best answer, but I think there were a lot of cases where it came out pretty well. So I think we're still testing to see how good it is. But yeah, that's what it does.
So I guess my summary on this would be, I don't know, what I've generally taken from it is if a point is closer to the camera, a small amount of linear motion would cause a larger motion from the perspective of the camera. And I use lighthouse and camera like mixed. And a farther point would be... Yeah, sorry, go.
Oh, sorry. Yeah, that makes sense. That when you get closer and closer to the camera, it looks like a larger motion to the camera. And what happens is that the different points on the head mount, if the head mount is like right next to the lighthouse, that's pretty much the worst case for this algorithm, because what that means is that the Z coordinate for some of the points on the head mount display are different than the Z coordinates for the other ones. So if you assume that the Z position for all of them is pretty close together, where it doesn't make very much of a difference in terms of the perspective divide, then it should be all right.
Right.
And I think that there are still, yeah.
Sorry, to just clarify, when he says Z, what he's actually talking about in this case is the Z from the perspective of the camera, with Z going into and out of the screen. So if you have a whole bunch of, I'm going to be talking with my hands for a second here. If you have, from your point of view, some points very close up here, let me see like this, some points like this, and some points like that, so very close and very far, then this approximation works out very poorly. But if most of your points show up in kind of the same plane, then the approximation works much better. And that's because the difference between things being close and far and how that size changes really kind of doesn't matter if their points are kind of all in a plane. So when he's saying all the same Z points, he's saying like the distance from the camera.
Yeah, I think that's a really good explanation. Are there any other questions about it? Yeah, does that, for the most part, make sense? Where you pretty much take a picture that, it's a 3D drawing. Let's say you had a 3D painting, and but you have it's drawn on a 2D page. So then you take you draw a point on there and you say that's the origin, and then you draw a line and say that's the up direction. This is the right direction, and this is the forward direction. And you draw 3 lines, and you say that's what it is. Well, we know that there's no way that you can draw 3 lines in 2D that actually map to the 3 lines in 3D, but we're going to do it anyway. And it's actually not so bad. And the funny thing about this projection is that it's been around for about 400 years. In artistry. It originated in China, so we can, I guess, say that it's the cheap Chinese way of doing it. Not to say that's a little bit. I'm making a joke. I hope that everybody finds that funny. But it originated in China about 400 years ago, and there are some really interesting paintings with some impossible drawings. There's a drawing where you have a staircase that loops around on itself and repeats infinitely. There are some really interesting corner cases where this projection can do some things that don't make any sense. But what's neat about it is that it's used a lot in architectural drawings, and it's good enough that if you draw something in that projection, that a person looking at the picture can look at it and say, okay, I can see what this is, right? So it's not bad, but I think from the perspective of an inverse problem, it makes the inverse problem of figuring out what the object is given the picture a lot easier than trying to solve the full problem. So that's basically the the approach. So if it's good enough, then it's good enough. If it's not, I'm hoping that if I do some optimization with that as a starting point, that we can try to iteratively come up with an even better position. And I think that could potentially be a really good approach, because if we have a really good initial guess, then there are some iterative methods to try to optimize an error function.
Okay.
And
Sorry.
I tried writing some code that optimized an error function first, but I wasn't using Lagrange multipliers. So, and I was starting from the identity vector, so I didn't have an initial guess, and it took a really long. It took like 2 million iterations to get to a good answer. So hopefully, if we could start with an answer that's really close to that, then hopefully it won't take very many iterations to get to a really good answer. As kind of a next step from this, is to use this as a starting point, and then refine the solution.
Yes. And just to clarify, I don't know if you saw the results, Dave, but I compared. So these points that are on the screen that I have up right now, the blue points are the absolute, and the red are the. If we use his guess, no, we need a 299 megahertz pixel clock. That's Eli. If we start with his points as a guess, this is just it. And then we create a quaternion and position rotation, so a pose out of his calculations. Then this is the results we get. And the answer is it's pretty good. So for right now, I think what I want to do, especially considering he got a much better answer for the distance to the lighthouse than I did, I think that we really want to just completely ditch the Charles lighthouse solver thing. And I think for the rest of this time here, I think I'm going to focus on trying to get Dave's code into a pose finding situation with LibSurvive in order to use it in the rest of the system. And if fingers crossed, if everything goes well tonight, we might actually be able to get your stuff in and tested. Sound good? I mean, I think we're kind of ready to move on. Does that sound good, Dave?
Sounds good to me.
Okay.
And I'll keep working on the Lagrange multipliers just in case. I'm sure it would be good to have an iterative solution. So
Right.
I'll keep working on that, but I don't know if I can finish that for tonight.
Oh, no. Don't worry about finishing that tonight. I think if we just get anything in, we'll
there are
be good.
just so many second derivatives.
Yeah.
It's annoying.
Okay. Well, thanks. I guess we'll
right.
keep moving around here.
All right. Good luck.
Thanks. See ya. Okay. And actually, I guess we need to take like a 5-minute break.
Okay.
Um,
I guess Dave hung up.
yeah, Dave hung up. I heard the beep. We're gonna take a 5-minute break, and then maybe not 5 minutes. Oh yeah, you're right. There will be an echo. Okay, that's solved. Is that a good view?
Sure, it's a fine view.
See, how many people do we have right now in stream? 71. That's not too bad. Let's make that a little bigger. Okay. I'm gonna move this over here.
So everyone, time for us to just ditch my thing on the floor and try to implement a
Poser using Dave's code. See, how does this stuff work? Ortho points, T float, okay. I think we'll be okay. So we're going to be breaking the code for a little bit.
Okay.
What I think you can do, if you are up for it, is trying to figure out, I don't really know. I want to find a way of looking at the code that's coming out of the disambiguator, and understanding why that looks terrible sometimes. Because, like, you know how, like, sometimes the dots hop around? I don't know why. I think some of it's just going to be, like, printfing and trying to make sense of that.
I think some of it also has to do with the fact that I haven't really played with it at all. 293? Yeah, 297. It is 297 megahertz. I feel like I almost wish that the resolution of the Vive was a little bit lower. So, poser. What?
This thing's
Actually, we should probably call this Dave Ortho. I will reduce the mic volume. Does the typing really? I just click something, it hit.
What are they talking about?
He's complaining about the typing volume.
Yeah, it was kind of reverberating to the table.
Hello. 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 I mean, I can't imagine being like that. Okay. I'll move the mic back some. Hello, can you hear me now? Is typing okay? Sorry. You know, I should probably turn it up so that you won't run into that. So, hello, hello. Yeah, that's totally ignoring me.
Where is the disambiguator?
It is in survive_data.c. Ooh, it's gonna need DCL a pack. I hope Dr. Chapman put the DCL a pack in the redist folder. He did not. So Dave wrote his own linear math library. That's what DC LAPACK is. It's based off of the idea of how normal LAPACK works, but, you know, Dave.
So we want to know why we're getting these little flashes of light
Yeah.
off from the main grouping.
Yeah, now keep in mind that, can I pull up your window? Is that okay?
Yeah, hold on, let me turn on the server. Alright.
I'll talk about what's on your screen right now for a second. Oh, come on.
Nothing. What's going on? Whoa. Okay. There we go.
Can you move your window all the way to the left?
Which one?
I can't seem to move your thing. It's stuck.
Which thing? This?
Yeah, move that all the way to the left.
Here?
Yeah, let go. Okay, so the box formation that it's making, that's fine. But the problem is when we have lights that are like all the way off to one side or the other. So like if you can make the window bigger too.
Oh, like what just happened?
What? No, that formation is okay. But when you have points that are like off in the middle of nowhere land. Oh hey, I was able to move your window now. Go figure. Okay. Yeah, make your window bigger. Okay, perfect.
So it seems to happen if it's moving around or something.
That's probably fair.
Try point it at the other lighthouse. Let's see if it happens more at the other lighthouse. Oh, it just got a flaky bit. I think that's... Oh yeah, no, it just jumped. Yeah, it's randomly doing some wacky stuff. What is going on there?
Oh, well remember,
You do have to have both.
if both lighthouses
Right.
are not,
We need to figure out how to get around that.
yeah. I guess I gotta hold like this.
It shouldn't be necessary at all to have both lighthouses to do that. I don't know why I do that. I look for both. But it's all in survive_data.c, so.
Looking for both is?
Yeah, well, like all the everything that, I have a light pulse, what does
I mean-
this mean?
This looks okay.
Every now and then it randomly does
Let me go
something.
over to our corner of, like, bad.
It looks good to me. Actually, that looks really good to me.
Huh.
What about the other area of terrible?
Over here?
We tried using the Vive at something other than the 90 megahertz refresh rate, and it just would not go. Oh, I just saw a flaky bit.
I mean, we gotta be at the edge of.
Right, but it still
That
shouldn't
lighthouse.
flake out that way. It basically said it saw one of the points in the middle of the scene for one of them.
That would be like here. Right?
No, I don't know. All the data's looking good right now.
Do you have it running on your computer?
Uh,
I'm gonna carry this one over to the corner.
I can't run it on my computer. Well, maybe I can. Hold on. I don't think I've... Okay, go for it. Although I'm not getting anything right now for some reason. I'm pressing O and nothing is happening.
Okay. Do you mind if I plug it into my computer?
Go for it. I'm gonna go hide your window again. It was mentioned that, yeah, we can't use blanking.
Alright. You can bring my window back if you want.
Oh, I can? Okay.
Yeah.
Go for it.
Oh, does it need to collect data first?
No.
Oh, okay.
Something's messed up on that. Oh my gosh, what's going on? Is that one yours or mine?
This one's mine.
Uh-oh. I mean, that looks... Oh, it's freaking out! No, it's fine now.
I mean, I had the edges covered with my hand, so that was probably the reason.
Can you move a little bit back because I can't see it? There you go. Oh, no, it just did it again. Oh, it's totally wrong. Okay, do the same thing for mine.
Okay.
Oh, freaking out. Okay. Oh, that's what is going on.
Hold on, over here.
No, it's definitely freaking out.
Okay.
You're gonna have to move back some.
At least they're consistent.
Yeah. Okay, now move it around some. Yo, what is... Yeah, there's just randomly these... What?
Okay, it's definitely consistently broken.
Well, the Vive works.
Yes. Did you see it? It produced like a diagonal line. Oh, I wish I understood what was wrong with this place.
Well, I mean, that's... Yeah, I don't know. That should have worked. At least they're both consistent.
Lee, terrible.
Eh.
What is going on?
I don't know. Do you mind if we just keep working?
Are you hungry at all?
Did she finish food?
Sure.
I'm up for eating while we work. We have tried playing real live games, and it totally does twitch out here, and we cannot figure out why it's twitching out.
It looks like there's a couple more minutes left.
Okay.
Alright, back to whatever. Do you mind if I put do you mind if I put your Vive on your computer?
Sure, but I don't know what that would accomplish, because I can't really do much right now.
Did you answer the JJ 101?
Yeah, I said that we had tried playing and it still was like twitching out.
What's reduced blanking?
I think that means like trying to run it at a lower res than it should, or like a lower Oh no, it's blanking. So what it is there's like a guard area around the actual data. Like there's like the actual screen size is bigger than the visible screen size. And reduced blanking, I think, is when you take that and you start cutting that down so that like you just have less pixels that are being sent that are 0 in the blanking periods. The blanking period is when there's no visible data currently being sent.
Mm-hmm.
I'm gonna have to figure something out because if I have the font size smaller, let's try 12. Maybe that'll be fine.
Well, why would there be a sensor reading of 255, 250?
255, 255, 255 is
255, 255, 65, 535.
okay. I don't know why they chose to do this with the Vive, but for some reason, when they send data, they can send like just data that's not actually populated with real data. And as far as I can gather, when you get a 255, 255, it means that there's nothing there. That it's just non-data.
They just throwing it out?
Yeah. Just throw it out.
Does the timestamp matter at all?
I don't think so. The reason I think it's throwout data is because normally that timestamp matches that of a previous packet. So it looks like they're using the same buffer to keep sending the data, but then they like say, hey, by the way, this actually isn't a valid packet.
Is the
Hey, Dr. Chapman, I don't know if you're still listening, but you really should be taking on the normals. That's really important. The normals will let you quickly weed out any complete nonsense locations.
I don't even want to be in it.
No.
Whenever you guys get hungry, there's food.
what?
Whenever you guys get hungry, there's food.
Okay, thank you. I don't know, I'm suspicious of these packets.
You're suspicious? What about?
The 255 ones.
I mean, I don't know that for a fact, by the way. This is just a bunch of guesses.
Nerol, if you're in chat, I think might be able to help Josh out, but I think that it doesn't matter.
How long does it take for this time to wrap?
Whatever 2 to the 32 divided by 48 million is. Seconds. So
Right.
2 to the 32 divided by 48 million seconds, whatever that is. He wants Matt Smith wants to know what HDMI version you have on your laptop. I don't know how to tell that.
I will see if I can figure that out.
He says 89.478 seconds.
That's less frequently than we're seeing the problems.
He says do xrandr space dash dash verbose.
Sure.
It's hard to believe that Dave has all this code and all of that runs in 1.6 microseconds.
I guess I don't know what I'm looking for here in XRAN.
Can I bring open your screen?
Yeah, sure. Actually, hold on.
Okay.
You can't, can you?
Mm-mm.
see it?
Give me a moment. Hello, Mrs. Chapman. Actually, Dr. David Chapman, is your mom a doctor too? I can't remember. I think she got it, right? Thomas Morris. Right now, up on screen is is Josh's HDMI stuff. Where do you find out the version from this? Maybe you can scroll up some.
Do I need to plug something into it?
I don't think so. I mean, maybe. Thomas Morris, does this give you everything you need? I guess Thomas Morris is no longer here. Oh wait, he says normally needs a device plugged in.
Alright. Hopefully this won't crash it. Oh, I plugged in the live.
Okay, I'll bring it back up. Okay. Scroll down some. Thomas Morris, are you looking? Connector number 2, number dimensions. Operating at 225 megahertz.
There's our fake EDI.
Yeah, EDID, yeah. Totally faked. He says he's looking it up.
From what?
I don't know. Gonna
I'm
minimize
just
you.
looking up how to do it.
Oh. How do you have so many pixels on your screen?
It's 1080p screen.
But, oh, I have to keep scrolling over because the right side of your screen is the Vive.
Oh.
Your screen is 4080 by 1200. Or the not Vive. He says it's version 1.3 or higher.
How did they figure that out?
Oh.
Alright, well I'm gonna end the VNC.
Okay. By the way, I have you minimized until you tell me I can, so I don't think it's that critical unless you don't trust me. Which is, to be fair, knowing my dad, I am not to be trusted.
Alright. Alright, what was I doing? Oh yeah, staring at this thing.
So sensor locations is not. Oh, that would make sense. Okay.
So,
I times 3 plus.
are you sure this problem we're seeing, it doesn't come in before the disambiguator?
It might, but I
Because
don't
the
know.
stuff that comes in a disambiguator already has the TLS times in it.
TLS.
Well, that's the variable that you call it. TSL.
Is that the UN32?
That's the time stamp SO TSL.
I think that's just the 32-bit int that came off of the headset.
What's that?
It's so inside the headset there's a clock that constantly counts up starting at like 0 and it just goes at 48 megahertz so you can synchronize your light data to your IMU data.
Is that the time that you're using, or are you using the system time?
Nope, using that time. You have to use that time.
Well, that's the time it would come in all screwed up, wouldn't it?
Check and see if it's screwed up. I don't think it's screwed up. It should always be going up. Except for the IMU. The IMU might end up out of order, but it shouldn't be too far out. I very much
No, it's
doubt-
not always going up because it has negative numbers. I mean, this is the
Oh.
delta or something.
Yes, that's also possible because it tells you when a light is, or when a sensor is no longer illuminated. So if one sensor gets illuminated, then another sensor gets illuminated, and then the first one turns off. No, first one gets illuminated, second one gets illuminated.
First one turns off.
Yeah, no, second one turns off, then first one turns off, then it'll give you a negative number. Because the start time of the second one to turn off was before the start time of the second time. So it is perfectly normal for that to be out of order.
Okay. So the number right before it is a big number. Is that just the timestamp marching along?
Probably. How big?
Big.
More than...
More than a billion.
Oh, that's weird. No, that's not normal. What do you mean by more than a billion? Oh! Also-
1.8 billion.
Check to make sure that it's not an invalid data point.
1.8 billion.
Right, no, look at the ID and the sensor type and all of that.
HND 14.
But what's the sensor type?
0? Which one's the sensor? Hold on. Yeah. 0. They're all 0.
Wow, Dave's code just compiled. So you think you have valid data that's coming in that radically out of order?
No, I'm just wondering well, it is out of order.
Can I open up your screen again?
Yeah. No, it's not out of order.
Okay. I could believe that it hops around some, but it shouldn't hop around a whole lot.
But it does look like an ever-increasing timestamp, which is what it is. Is there a way that we can just log the ones that are wildly out of place? Like, I know you pick up on it visually.
Write it out. Log it to some file or something.
No, but I just only want to log those.
Yeah, you should do that. That would be a good thing to do.
But how do I know which ones they are?
Come up with some criteria and printf if you think it might be a crazy one.
Like further than some distance away?
Or time or something.
Should we grab some food?
Maybe like another 10 minutes.
Yeah.
Because then I could probably actually get this,
There's really not much to the disambiguator.
No, there's really not, and that has me a little scared. Somebody else wrote a much more complicated one, but I couldn't get it to work right, so I ended up just abandoning it.
Half of it is just the thing that does the OOTX. And that doesn't matter.
Jakov just noted, oh, survive! Vive. I get it now. LibSurvive.
Mm-hmm.
Um. Your laptop is...
It's annoying. I am not buying a new one.
Sandra, are you into programming, or is this just a random, you happen to stumble upon this live thing? Survive, poser, H, survive object, survive config, context. That should be in survive cal.
How did you decide on the pulse window values?
Which ones?
380,000 and 70,000.
So if center is 200,000 or 400,000, no, 200,000, and I don't remember, it had to do with being in the center, and you can only go so far to one side or the other.
Okay.
Maybe
That's
70,000
from
is a
the
little
beginning
low.
of the sync pulse, right?
I think so. Sandra, it's have you ever heard of an HTC Vive? We're right now trying to basically code that same sort of thing, or like the software that runs on a computer for it, but in hopes that we'll be able to develop our own hardware that we can then use with basically the same sort of tracking systems that the HTC Vive uses.
Light processor. Light proc.
Say what?
At the end of the disambiguator, it goes off in a light proc.
Can I pull open your screen?
It's off the bottom of the screen.
I mean, I can't even open it.
You can now.
Okay. What am I looking at?
Just wondering where to chase that at.
I would just grep for where it's used.
FBP. Okay. The full flight process.
Okay. So now I have to figure out where this is broken. And 118.
Survive process.
Data undefined reference cal LH find. That's okay, because we're not using that function anymore. We're now using this function name. CD arrow that config poser. And instead of CD, we're passing in CD arrow HMD. And we're passing in.
Could this be related to the fact that we don't have, we're not using the OTX data yet?
I don't think so, because it is so drastically wrong when it's wrong, or at least the outcome is so drastically wrong. The OOTX data would tell us slight
Yeah, it would be
changes.
consistently wrong then.
Yes.
Yeah.
Yes, the OOTX data would only adjust. Did you ever see Neral's video on it?
Yep.
Okay. And by the way, I don't want to deal with that. If you can deal with that when you get there, that would be super cool. What? I don't want to deal with it. It looks like it's a lot of fiddling and finagling. Full scene data. So we have that. We gotta go create that from the existing data. FSD. Poser.c. So we're gonna create that data in there.
So, Dave's thing is a poser, right?
Say it again?
Dave's code is for posing.
Yes. Yes.
So remind me again why it shows up in square sometimes.
So, because we're displaying both lighthouses on the same screen, if it say updates the X from that lighthouse on a given sensor and the Y from that lighthouse on the same sensor, it'll display it over here. So it uses this lighthouse's X and this lighthouse's Y in like the wrong lighthouse, and so it displays it in the wrong place.
That seems like that should be fixed.
Do you want to fix it? That would be in calibrate.c, because right now I'm using the same data.
I could see that being an issue.
But that's just for the user presentation. That's just for showing it to the user. But if you want to fix it, I think that would help people understand, and I think it would produce less frustration. If you look in calibrate.c, when I set that up, I just throw out which lighthouse it is, and that's probably the wrong way to do it.
Alright, that sounds not that hard.
Okay.
So is that just for the rendering, or is it deeper than that?
That's just for rendering it. That's it.
I just have to find your part where you're drawing, basically.
No, it's actually for the data when it's getting the data from that level of the program. Look in calibrate.c in the callback.
Handle calibration?
No.
Survive cal angle?
Yes, I think.
Survive cal light?
I think that's it. That's probably it.
Cal light?
I don't know.
No, this isn't it.
It's probably cal angle.
That I believe. Wait, this is the one where I made sure it wasn't paying attention to the watchman. No, this can't be where it's at.
Let's see, will this compile now? No. So the reason I add the 0, Muron, is because it makes it so it's like homogeneous with this, because I will have to add 1 in this case. I won't have to add 1 in this case. And here I want to mark off that that's actually kind of like a self note that that's going to be the axis. So this is axis 0 and that's axis 1. Ordinarily, you would just kind of use that as a multi-dimensional array. I guess that's more of a style thing. Why is this not working? What? Send IP. Oh, that's part of this code up here. Uh-oh, warning. From incompatible type. Oh, it wants it to be a generic version of that. So it wants poser data. That's okay. I can give it poser data. Bingo! Calibrate. Oh. So we used to require a watchman thing, a common point on a watchman, but we don't really operate that way anymore.
Does Dave's thing get rid of that?
Yeah, doing it this way just obliterates. I don't know why we didn't. 244.
Food?
Oh, give me a second. I'm almost done.
I mean,
You know, it really would be nice if the things didn't keep flickering. I really don't like that.
that's just from the lighthouse stuff.
What do you mean by Thomas? By that, Thomas? Goal is to get the thing itself to be able to process the lighthouse data with peanuts. Seg fault. Okay, let's give this another minute. If I can't get it then we'll just go eat.
Sandre asked if it's just 2 guys working on this.
Nope, it is a boatload of people working on this. Where did he ask that?
Up a little bit.
Oh. Got config poser null. What are you? What's confusing?
I don't understand how it can be getting confused about these points in which lighthouse was doing the scanning.
I don't know either.
Because if a lighthouse, it's lighthouse 0 scans X.
Oh, that part
And
I
then
do
lighthouse
understand.
1 scans X. Right?
Yes.
And it completes before it starts, the other lighthouse begins, right?
But it updates the position of the point in X for this lighthouse, this frame. Then it renders it. So because this one just moved it, now we have this lighthouse as X, but we don't yet have this lighthouse as Y.
So it's really just the frame is rendering in between the sweeps.
Yes, correct. So the idea that we should be using is store the pixel data is a bigger array,
Now,
like
is
twice
that-
as big.
Is that buffer points, PTS?
It's been 2 months since I wrote that code.
Okay.
Okay, it says stage 4 succeeded, but it didn't run Dave's code, so. It did run Dave's code. Forgot to do that. Let's try this.
Fingers crossed. I'll be done and we could go eat whenever you're ready, but let's. I hope this
X1,
works.
Y1, X2, Y2.
So what Josh is working on right now, do you notice how some of those lights are flickering? It's because we're overwriting the data while it's being displayed. What we really should be doing is making it so that it's stored in 2 separate buffers, so we'll be able to get a really clear picture of what this lighthouse sees and what this lighthouse sees. Probably make them different colors too.
Stage 4 failed. That's just because I didn't return a value. Let's see, what does Dave's thing say? Dave's code says... Dave's code did a lot of crazy things. I'm not sure what that means.
Do you use SDL for the debug window?
No, we use raw draw for the debug window. Raw draw is available.
Did you write it?
Yeah. It's completely OS independent, and it runs on just about anything. You can even actually run it like on the. Do you remember the video I made where I was broadcasting NTSC video on the ESPN8266? You can use raw draw to do 3D rendering on like buffers in C. Well, Dave's code is coming up with answers. 3.8 meters, which is, I guess, okay. Best aerodynamic. Okay, what is going on there?
Well, 3.8 meters is correct for one of them, just about.
The heck? Dave's code, what's going on? I'm almost there, Josh. Raw draw is very fast. You could use ray tracing. Really, raw draw is like SDL Lite. It's just really small, and you can just include it in your project, and it's really geared to operate on like peanuts. Like,
That's not really going to help you with ray tracing, though.
no, you're still gonna have to, like, if you have a buffer and you want to display to the screen, you just say, hey, raw, display this buffer to the screen, and it just does it. But you got to figure out what to put in the buffer. Okay, that's really bad. Why is everything not a number? Everything is not a number. Why is Dave's code so broken? Actually, let's also peel that back. So instead of spending 1024, let's make that much quicker. Let's only do 128 points.
I need to look up
Are
those
you-
A codes again.
Say it again?
I need to look up those A codes,
Yeah.
the axis codes, because really you just want to switch after the y-axis.
Yeah.
Just double buffer the points. Okay.
So something going into Dave's code is super bad. I don't know what it is, but it is time for us to take a break. I have forgotten what CNFG means. I'm sorry. But I'm going to go on a break now. And Josh, are you ready? Do you want to have a few more minutes?
Give me like 5 minutes.
Okay. Then once Josh is ready, we're going on a
This
break.
is gonna go infinitely.
I just... Huh. There it is. Found it. Play ad. Let's try running this. Come on, Dave's code.
Charles, can you open up VNC?
Okay. Let me see if Dave's code burned. Oh my gosh, it's on fire. Bunch of nans. Okay. I have it open. Nope, still wrong. But it did. Yeah, it still broke. But it did. Yeah, no. Try to make it so you have like a sensor that would be visible from both. Yeah. So what you're getting, see, when you have these points that are not in the two main things, but they're on the same axes, that means that's where that's coming from.
Up there in that top right corner?
Yeah.
Okay. Break time.
Okay, break time. Play ad. What do you think? Can we make it real quick? Back in 5 minutes?
Yeah, 5-10 minutes. Don't let them stare at your computer.
There we go.
Actually, I know what I can do. I can play a song from Brendan. Because I'm actually allowed to do that. I'm gonna have to plug this into here. Why is this so bad? Oh, I need the stupid dongle later. Why you no go out right port? I want to listen. Why is sound always so painful, Josh?
It doesn't make sense to me. Is it working? Oh, I'm upstairs.
you guys hear that? Was that all in sync with the thing? So if I go like... Is that all working? Yes, no? Okay. You guys get this for like 10 minutes. Looks like the timing worked out. Oh. We should probably play something to... Did I miss anything in chat? What is that? Play ad? Yeah, let's play an ad while I get settled back in. If you guys could figure out how to run the Vive at a lower dot clock, that would be super swanky. Because if we're going to run the Vive on a Pi, you know... I really wish I knew what was causing the problem that Josh is having with the Vive. It is clear that something is reflecting off of something else, but what it is, I do not know. It's so perplexing. I feel bad that Josh is spending $500 on a used Vive and just is so annoying at his house. No, the PC wasn't set up. It's not that. So right now what I'm doing is I'm trying to just print out a bunch of variables. And see what exactly is going on. Why is Dave's code nanning all over the place? Nan, 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 nan. So usually when you try to find the nans, this particular Vive I used at home for almost a week and there were no glitches. So I don't know what's up with that. That data looks pretty good. Excuse me.
you doing?
Trying to get Dave's code to not crash. Middle number is nan. Y is YY nan. Oh, Dave. He never protected the variables.
Oh well.
So if you take a square root of something that's like almost exactly 0, but not quite 0, it can just break everywhere. Hello, Dave's code.
Hey.
It's like the longest live stream ever.
I don't think so. We did like a 5.5 hour one once.
Oh wow.
That was rough. I was ragged by the end. I did it most. I had like 2 breaks, like itty bitty ones. Do you want to bend the? If you want to back that back out so you can see Josh and me, that's probably best. Like all the way. Oh yes. Aim it up some. Aim it a little more towards Josh. Back up some more. 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 Okay, good, good. Now if you aim more towards Josh, then we'll be able to get the vibe in view. So like more that way. A little bit more towards me. A little more towards me. Okay, and now aim it up. Yes. Up more.
More up more.
Yes. More. There we go. Looks good. Now we're all centered. It's lopsided, but that's fine. I like how this has basically also become like everybody. There's a bunch of people in chat talking about things that are tangentially like related that we may end up addressing like a few weeks down the line. So they're like laying out the groundwork for us later.
Yeah. Oh, so this function doesn't ever actually get lighthouse index numbers.
What? Can't it infer that through A code though?
I don't think so. No, I don't think so. A code just gives you skip data access. Or access.
Which function is it?
I'm looking at my light process in calibrate.c. I could be completely the wrong function.
No, that looks right. You can definitely tell which one it is from the A code. I think 2 and 3 is one of the lighthouses, and 6 and 7 is the other lighthouse. Yeah.
I don't. Can you explain your reasoning on that?
Just closed it, hold on. My reasoning on that is that there are a total of 8 different possible A codes.
Yeah.
You see that 0 and 2 and 1 and 3 and 4 and 6 and 5 and 7 are all the same thing. So that means that that's the data bit. The 0 or the 1 bit is the data bit.
Yes.
1 or 0.
Yeah.
Then 0 and 2 and 1 and 3 write to the x-axis and the y-axis of buffer PTS accordingly. and 4 and 6 also write to the x-axis, and 5 and 7 write to the y-axis.
And 1 and 3 would be a y-axis, right?
Correct. Notice how it says jump offset times 2 plus 0, jump offset times 2 plus 1, jump
Yes.
offset times 2 plus 0. I think it should be times 4 plus 0, times 4 plus 1, times 4 plus 2,
Oh, I
times
just
4
meant
plus
a
3.
two-dimensional array.
That would work too. I really have to get out of that habit. We're gonna have to go through the code, and like a bunch of places I used one-dimensional arrays to represent multi-dimensional data. We really need to switch it over to using multi-dimensional arrays. It's a bad habit I have.
So I will just arbitrarily assign them to one or the other. Does that sound correct?
Mm-hmm.
Okay. What is CNFG10X?
That's where it starts drawing text. Pen controls the text location.
Next pen one. Okay, so why do we care? Why is it drawing a text location based off of what's in those buffer pointers? Or buffer points?
Maybe it's not. I don't know. Normally I use it for that. Maybe there's another reason behind it.
Oh well, I'll just copy and paste.
This error. There's no reason to do that, Dave.
Oh wow.
What? Is it good?
It's okay. There's this other issue. There's an issue now where.
Can I look at your screen?
Yeah. Let me fix that for you. I think there's an issue where the sensors may not be updating.
That I have seen. But that happens through
No, but
any...
it's because I'm not getting data from them.
Okay. Go move it around. Oh, so there is another thing that I do where if you haven't gotten data from a sensor in a while, it fades it to black. Although I don't know what we're looking at here. Something looks hosed. Oh, it just turned off.
That was my shadow.
Yeah, that looks like mess.
It started out nice.
Maybe there's another array that's used to like time the data out and to throw it away.
Yeah.
By the way, guys, if you can possibly output with the Pi, that would be pretty cool. I'm disconnected from your screen.
Okay. It seems to, when you disconnect, it seems to close the VNC server, which is okay.
Hopefully it's only going to run Dave's code twice now. Spectacular. This error is still 2189 though. It's really high. And 758. Let's see what this data looks like. Actually, he says 3.5 2.5-ish meters and 2.6-ish. It's just wrong. Oh, you know what? Can you rotate the headset so it's 90 degrees from where it is right now?
That one?
Yeah. That could explain why there. That's probably much better to do depth testing with. In the meantime, I will set up the graphs though. Dave, why?
What's wrong?
Dave described this problem. I don't know why it is, but sometimes his thing will just make everything off to one side or the other.
Huh. That's weird.
Whatever, I'm gonna go implement his thing, and then I'm gonna go throw it at him, and he can hopefully fix it.
Let's see what this next set of data looks like. Ooh, that looks rough. So you get the distance right. 3.7 meters. Yeah, that's wrong. Oh, wait, no, it's exactly right. Let's see about this one. 2.83, that's pretty close. Not too bad. Data looks a little wonky.
You can go back to my screen if you want.
I can't.
Yeah.
Okay. Ooh, that looks much better. There's still every now and then freaky points.
Oh, yeah, that has not been solved.
Ooh, that's a really set of freaky points.
But I think they're actually freaky points.
That I can believe. You should probably commit this so that it doesn't confuse everybody, as it is right now.
I don't think you'll be able to make a square that hangs around for very long.
Yeah, there's definitely some data points that are weird.
But they should not be flickering like that. I don't think.
Well, flickering is okay. They shouldn't, like, freak out and go in the middle of nowhere land like they are sometimes.
It's definitely when you start moving. If you're stationary, it's fine.
That points more to a problem with my thing than anything in,
Yeah.
No. I saw something there. Move it around just a little bit.
Yeah, but that one right there.
I don't see it. I guess try moving it around again. Do you want to aim it towards the terrible corner? Yeah. Oh, hey, stop. Stop. Go back a little bit. Okay. If we can get that to happen more reliably, okay, then we can find the source. That could be it. Okay, you're gonna... Let's see, is it this lighthouse? Okay, if I cover this.
No, it has more to do with my head than anything.
Which lighthouse is the one on the right?
I don't know. You just want me to make each lighthouse its own color?
No. I'll shake this one.
That's gonna throw it all off. Don't shake it. That's gonna mess up the rotors, isn't it?
I'm not going to shake it harder, but okay. Aim it straight towards that one.
All right. So the one on the right is that one over there.
That one, you think?
Yeah.
Okay. So let's try to get it to freak out again.
So wait, are we trying to figure out a reflection or?
Yeah, I want to find out. There was that yellow point that was freaking out. I want to find out if it's something environmental. So you're going to have to move around again, I guess, to find that again, or something.
Do you see it at the bottom?
No? But don't worry, if they're down there, that's probably fine. That's probably something wrong with the disambiguator. I don't see it freaking out at all. Do the thing where you like we're rotating right to left, because that seems to find it.
How about I just put it on my head?
Yeah, that's fine. I'll watch and I'll tell you what to do. I don't know, for secondary you got a pretty good set of bad points.
You just twist it up.
Yeah.
How do I untwist it?
You'll want to turn from looking from above counterclockwise. Oh no. Okay. Okay, go. Again. Okay, I guess rotate back and forth some. Walk around a little bit. Waiting for it to do the thing again. You're pretty far off to the. You want to back up some. Back up some more. More. Okay, I guess look around. Just look around you. Stop. Go back some. To your right. Right? Look up around, like look around a little bit. Go down some, like bend down. Okay. Up. I can't tell what causes it. Do you want to just, let's find it somewhere else that's more reliable, I guess. Whoa! Stop. Go back. Hey, there. That's it. Oh, it went away. Darn it. No, you can't see that lighthouse, so I can't see.
No, oh wait.
Okay, I guess keep it in whatever. There. There. Oh, how do I find out which?
I wonder which sensor that is.
We could find that out. Ah. That was weird.
What?
Did you see it like jump?
I saw it just disappear like that.
Oh, it's because I'm in the way.
No. Because that's over here on this side. No, no. No. Okay.
Oh. I wish we could get this to. What is up with that? It's still going on?
Yeah, ooh.
What? Oh, weird things happened.
I cover this sensor. It's weird.
It does get weird.
That shouldn't happen.
Maybe you're causing it. I don't know. Hold on. Do it. Hold it and steady so it's causing it. Okay.
This is because. That was me moving my finger.
Okay.
If I move my finger, that yellow dot will go away.
If you move it onto it or away from it.
Away from it.
What?
Well, that doesn't make any sense.
That can't be. Can it be environmental? I don't think it can.
My finger? I don't know.
I don't know. Like, let's get it to come back.
No, it's up there.
No, that wasn't. That was. There it is.
It's starting to darken.
What is going on? This is madness. Watch this just be some bug that's been there the whole time, but we've never really paid that much attention to it till now. Let's see if anybody's seeing anything in chat. I guess just keep walking around. Let's see if we can find somewhere that's just worse.
Well, the square problem's solved, right?
Yes. So you should probably commit that. And you should probably pull, because there's a lot of other changes. Maybe there's just a derpy sensor.
I think that's like sensor number 9 or something.
But when it's in direct contact with the, or direct sight of the light, it's fine.
Oh, it came back.
That's a different one. Oh.
How hard is it to print a sensor number next to it? Like, super tiny.
Not hard. You have to set the pen X and Y, and then you have to do CNFG draw text. Whatever, let's just call Dave's code good enough, and let's just implement it.
Alright, well I guess I'll commit this then.
Let's not do it that way.
Did you commit?
Hold on. I've committed a fair bit, but I haven't. So you should probably just commit, I should update, and then we should go from there.
Alright, push.
T0313 and 23.
Good time, we're alright.
Give me a second. Yeah, it's fine. It's probably too much on me. Move it back some. It's also lopsided.
Oh, it is. Any less lopsided?
Don't worry about it.
It's fine. How does that work? If you want to invert the pose, so that's really far Z. I say there's an X rotation.
Is the pose a quad?
Well, it's a quad and a translation. I'm trying to figure out, do I have to rotate the translation by the forward quad or the reverse quad? I can't remember. That would be,
Is that old translate or rotate or translate, right?
Yeah, that thing.
Yeah.
why am I so bad at this? I've never gotten good at that.
So what are you trying to do?
I have a position of the lighthouse relative to the object and the orientation of said lighthouse.
The orientation of the lighthouse? You mean like the
No,
position of what?
do I? No, because the position is like very big in the Y, so it's where the object is relative to the lighthouse.
Anybody have any ideas in the chat?
Somebody's actually installing Xorg minimal on a Pi 2. I don't know. It's so hard to think about. And even if I was more awake, it'd still be hard because it's. So that's going to be a very large Y. So that would be from the lighthouse's point of view where the object is.
So what are you trying to figure out again?
I'm trying to determine the pose of the object based on the lighthouse's point of view. So that might actually just be it. Yeah. I think that's actually it. I think we can just return that. I need to do all this wacky matrix junk afterwards. So hopefully what we'll have is something that poops out the quaternions and offsets. Although I don't know if I actually print the offsets, so. Oh, it just did. Quad. That's the final quad, but I don't print out the offset, so.
think I should go do that.
The before and after offset?
You know how the matrix holds the X, Y, and Z?
Mm-hmm.
That. So yes, this is actually going to give exactly what we want. We're going to have to invert the output to get the rest. To get the what I will want is to determine the position and orientation of the camera based on this information. Oh,
What?
I already did the thing. I just didn't. I wasn't paying attention. Yeah. So that's definitely the quaternion of the object and its position from the camera's point of view.
Okay. Is that right?
I mean, it looks right. Probably.
What would it look like if it was wrong?
I don't know. Let's see, are the numbers about right? 2.7. That's off.
Maybe we should remeasure it, because I'm pretty sure I've moved some things around.
I'm not going to worry about that right now. I want to actually just press forward and get this code done. So if I have that information, then I can go back and I can stuff it in the object. So survive.
Don't forget, the time changes tonight.
To what? Which direction?
The bad one.
Okay, I'll remember that. We should probably end by 10:30 then. So we got another hour. So see how I have survive pose from lighthouse pose?
Mm-hmm.
Yeah.
So a pose really is the position and rotation of something.
Yes.
Okay, that's what I thought.
Right.
The
But
pose that it's in.
right. But it's a different thing than like a transformation, like what we're used to dealing with game engines, because it can only affect rotation and position and nothing else. You can't scale.
Oh yeah, okay.
You
Of
can't
course.
skew. You can't
That's
any of
fine.
that junk.
Mental capacity fading.
Yeah, I'm definitely starting to fade myself, but I feel like we can just push forward and we can make this happen. Possum Road.
Huh?
Dot pos.
So once this is done, what is the event? What's the end result?
What the end result will be today, if we can get this to work, is we will be able to move the thing around the room, and it will tell us in 3D space where that lighthouse thinks it is and where that lighthouse thinks it is.
In relation to.
It's coordinate frame right now. If that's the origin, you can figure it at the origin.
So when it runs the calibration routine first.
Yes.
Okay.
And then we pick it up and we move it around and we see if those things are anywhere close to similar. And if they are, we will have succeeded in a very great thing.
some point we're gonna have to go through and like refactor lots of stuff.
Yeah, that will definitely have to happen. We're not there yet, though. We got to get the stuff to work first. Okay, so that finds that, and then I should be able to invert it, and that should tell me the lighthouse's position. Okay, so if I'm the lighthouse, or sorry, I'm the visor, I'm looking up right now.
Uh-huh.
I want to know the position and rotation of that lighthouse relative to me.
Uh-huh.
So I have to rotate that vector from the lighthouse to me. I think by whatever. Let's just try it one way and we'll try it the other way.
Yeah.
All right? Even though it's a lot of work to switch, let's just
It is.
yeah. It's worth just doing. I'll make a note though that we might have to swap. So
I think you want to do a translation and then a rotation.
no, well, you still have to translate, but do you translate based off of the rotation or the inverted rotation? Is anybody even watching this anymore?
I don't know.
$43. That's not bad for not doing anything. Okay.
We don't know what we're doing either.
Paul Martin. So what we have is we now have a pose. We have pose information of where the object is relative to the lighthouse. Maybe.
Is it the pose of lighthouse relative
It's
to the
the-
object?
The translation is almost always in Y if the object is in front of the lighthouse. So it's where is the object relative to the lighthouse? But we want to find out where the lighthouse itself is relative to the object.
So this is part of the configuration stage. The object we're operating on is of the HMD. So that's Select the object from HM. Oh, from Lighthouse. Okay. Just scrap all of these and buy one of these. What is this? DIY. Wait, did I ever actually code that? I didn't think I coded that.
Oh well. Do we need them?
We will. I'm gonna basically pretend it right now into hopefully being.
And it's not pretend.
I don't know. Survive. BSD, there it is. Base station data has a pose, so. This is called CTX in here. This function is entirely too long.
CD.
No, CD is the cal thing. I need the context. BSD, LH.
Why not? Why do you do this? Just take that away and just make it plus LH.
But it's the address of it, Josh. Ampersand means address of.
So does pointer plus offset.
But you'll see I'm doing more. See?
Okay.
Okay.
So it's just
Right. LHP from the inverse of OBJ from LH. So that would be LHP arrow. LHP arrow pos
Reading your code is a nightmare.
from LH arrow wrote piping in OBJ from LH arrow pos, and now I'm going to take in OBJ from LH arrow wrote 0 times equals -1. Okay, that should flip it around. Got it.
Maybe.
Let's also make oh, I'm a dummy.
What did you forget?
Let's make it so the first cal will do this. So we'll do this really awfully.
Oh, no.
Static int I or int first cal.
Oh,
We're not going to keep this.
okay.
Or no, it would be not first cal. If not first cal.
It's getting later.
This code is so terrible. Okay, now what we have is we're going to have a position and a rotation of the headset relative to that. So we can just ditch the rotation because I don't care about that right now. I just want to get the positions of the headset.
What does the first cal have to do with anything?
Hmm?
What is this for? Not first cal.
So the first time you calibrate, it's expecting it to be face up. But every time after, I'm just going to start printfing junk. I don't actually want it to have an effect.
Not first cal. You should probably set that to something else somewhere.
Why?
Be-
If not first cal.
You could say, like first cal equals 0 and take off the double knot.
Well, no, first cal equals 0 means it's not the first cal.
That's why I make it equal to 1.
Can you do that as a static variable?
Yeah, static just means run it once.
Yeah, but how does it know what to initialize it to? Oh,
1.
wait. Derp! Okay.
The problem is now you have to set it to 0 at some point.
Yeah, I'll do that right here. Done. Okay, so now what we do is I want to have a position in 3D space from the lighthouse's point of view. The position.
Doesn't this need to be down here?
No, this runs first.
No, it doesn't. It has a knot in front of it.
There we go.
Okay.
Okay. Moving on. So now, fprintf std error are magic stuff.
No, that's not right.
If you initialize static variable, I don't think that's true.
Nope.
Well, we'll find out soon enough.
That's the magic of a static variable.
Okay. I want to rotate the position by the lighthouse's orientation. And I want to write that to a new position 4 because we're not going to use it. And then I want to... two other people say it'll sign it every time.
What? I don't think so. There's no way.
Whatever, we'll just play it safe. Okay, everybody happy with that? We're moving on. Okay, there's no way this is gonna work. What did I do wrong? Okay, oh my gosh, no pointer problems.
Huh.
The address of CTX.
Just put some more parentheses around it and it'll be fine.
Oh, this is supposed to be dot pose, okay. Next one, 502 is, oh my gosh. That maybe? Oh, it's need to include limit.
That guy's right.
We'll try it both ways. You're actually fine. I will trust you, Josh. I will go out on a limb, and I will trust you. And if you let me
If
down...
it's wrong, I have some serious problems at work.
Oh, no! Okay, we'll see. Okay.
That guy makes a point.
Okay, we're getting closer. 513. I think it's this one.
It's safe, maybe.
See, maybe. Okay, let's collect some data and see what it poops out. I think Josh is wrong. It should be printing this stuff. It's not.
Moving outside the if statement. Keeps its value while outside the if function.
Whatever. You know what we'll do? We'll just put this at the top of the file. And we'll remember to delete this later.
Okay.
Okay. Wait, what's going on? Why is it not printing? I did something else wrong. Maybe Josh isn't wrong. First cal. Okay, you know what? If static int not first cal equals 0. If not first cal. Not first cal equals 1. Okay, let's try this.
Yes, they are different.
Uh-oh.
Hmm?
Something else is going on. Why is this not getting... Oh! Bombs! That's wrong.
Need a while loop there.
What I actually want to do is this and here. Comment that out. If true.
It,
Delete that. Okay. It's gonna take like 2 weeks just to like clean up. If this works, which it won't work because there's no way this is gonna work. They're all zeros. Why are they all zeros? Stage 4 succeeded in inverting 1. So I just want to print up everything. Oh, you know what? It's because the quaternion is hosed.
while not wait, what? While not first count. What's going on?
Okay. We'll be okay. What's wrong with that?
Is that not a pointer?
Oh.
Did it crash?
these work? Those look like perfectly reasonable numbers. Whether or not they're right, I don't know.
Those are numbers. Can you stick that static back into function?
Do you want me to?
Yes.
Okay.
Maybe not in the if statement, but at least in the function.
No, let's just shove it in the if. Oh no, well the if statement's there, but it's always true. Ooh, you know what? There's a really good test for this. If we run this and it worked, it should say that the object is back at the origin. So we should just be able to see this, and if the output is back at the origin, which it's absolutely not, then it's perfect. But it's not okay, so let's try to figure this out. Maybe we have to invert this rotation first. By the way, you're totally right, Josh. All the other people were just wrong. Somebody says it's different in C++.
Not.
That's still wrong. Why is that still wrong?
What does it do in C++? I can't remember.
Gosh. That definitely is wrong. That should be moved down. Okay, let's try that.
Everything with global static storage term. Huh.
So got that. That looks interesting. Okay, that looks wrong, but this data looks really good.
Is that for the position of the lighthouse?
Yes.
And rotation and... Yeah, that's the matrix, right?
No,
No?
it's not matrices. It's just position in something, position out. Can you try to tilt it up so it's almost straight up and down? And oriented so that both lighthouses, like oriented,
This
like,
one, right?
yeah, that one. Oh wait, is it?
I think mostly.
Can you check? I don't know. What is this plugged into?
Oh.
Okay, that is the right one.
Yeah, how do you want me to orient it?
So that it is directly in line with the two lighthouses, like in the middle, and so that it is oriented so that its top is pointed towards one. No, other way, 90 degrees, but move it so it's physically in between the two.
It is, right?
Is it? Like in line, like really close.
It's really close. No, it's really not.
Okay.
And try to orient it so that it's almost straight up and down. That's probably fine.
Okay, I'm running it now.
I have a, hold on, I have a,
Oh, there's some point in it that's wrong. Oh, hey, that's actually kind of useful.
hey, I have a laser.
Josh.
somewhere.
Josh, it's sitting on the floor. Oh, I'm still running the old code. Everything's fine. Never mind.
I'll be back.
Okay. Okay, so that's what the matrices are. That really does look. No, it's not believable.
There's no way that's that far out.
So this is the position from the lighthouse's point of view.
Okay, thanks.
I want to press forward because if we can get this tonight, that would be such a landmark thing, and I feel like we're really close.
Unfortunately, it's not.
Oh, that's not a very good line.
No, it's not. Oh well.
You know what I forgot to do? I forgot to add back in the position of the lighthouse. OBJ from LH plus 0. No. Plus 0 plus equals OBJ from LH. Wait, that's growth? Is that right? Oh, plus equals LHP plus 0. Okay. 1, 2, 2, 1. Fired up. Okay, go. There's like 8 things that could be reversed, and I don't know what they are. But I think everything's there now. If we just keep reversing things, it'll be fine. That's really wrong. Let's move that back down here.
Oh no.
Let's move this into here. So that's step 1. Okay. One of these things is gonna work. You just gotta try them all, because I'm too tired to figure out which it actually should be. That's super wrong. 5 meters. Okay, no, I actually have to think about this some. Why is that? Object from the lighthouse's point of view.
So we're starting with data that is basically that. Charles,
Hold on. Yeah?
saying it's that far away in that direction.
You're gonna you should stand somewhere some people can see you. Like, no, they can't see you there.
So from this lighthouse over here, I was starting with data that says it's that way, that
Yes.
far away.
I am the lighthouse, and Y goes into me. Is that right? It's supposed to be Z goes into me.
I don't know.
David, why did you have to make Y forward? I don't even know how to transform from that.
I mean, I guess, is he using Z as depth?
Yeah. No, he's using Y as depth, but it's still a right-handed coordinate system. It's whatever that is on the front. So it's if it's Y is forward, and we want to make it so Z is forward. That doesn't affect X.
but it means that it would be
it's an additional rotation.
it'd be negative y or negative z. Okay, I think I got it. Okay, let's try this. Also, still the other things could be flipped. So if this fails the first 3 times, it doesn't mean anything. Okay, that's reasonable. That's totally wrong, but, you know, we're making progress. Okay, let's flip it one way. So let's use the rotated. That's super wrong.
No, it's not that wrong.
But it is that wrong. It's so.
It's well, I mean that's wrong.
That's no.
That's
It should be positive z.
So if there's no rotation on the lighthouse, which means the lighthouse is pointed straight at the thing. Oh, that's interesting. If the lighthouse is pointed straight at it. No, because it would be. Maybe it is from Z up.
Okay, we can solve some of these things by writing a little test program. The bottom here, I am going to make up
so
a point.
really you have a vector, right? That is as long as it is from the lighthouse to the thing. Right? Why not? Can't you just rotate it 180 degrees around the perpendicular axis and then translate it the length of the vector?
What?
You just want the vector to point in the opposite direction and then translate it that length.
Yeah. Is that simple?
I don't know.
Flipping it around is easy because that's just the times negative 1. I don't think it works that way. I think we have to do. Flip that. LHP plus. Longest live stream ever. I just realized something. This should be the position of the lighthouse. And if it's off by that much, that means that can't possibly be right. So something is seriously twisted here. So the position of that lighthouse relative to that headset should be positive z, positive y, 0 for x. And the other one should be positive z, negative y. Let's see what we get. we get positive y, negative z, positive y, negative z. So that's super wrong. Let's try it the other way real quick. We got, hey. Well, why is it negative z though?
Well, you said one of them had to be positive and negative.
How off, do you think it could be 0.7 meters off center?
Center of what? The line between them?
Yeah. Half a meter?
I don't think so, but I don't know. Maybe. Hey, let me shift it over here.
I'm going to try undoing the transformation that Dave had. Or I'm going to try undoing the transformation I made that tried to account for what Dave did. Okay, I'm running it. Don't touch it, don't touch. I'm not sure based on what I'm seeing now from Dave's code.
Not sure about what.
Somebody said something that...
I said, move out. Oh.
So that looks relatively good. Because that's a positive z, a negative y, a positive z, a positive y. Very small values for x. Okay. When it's done, it produces something that's completely in the middle of nowhere land. Actually, I'm curious what happens if we do this in the other order. Does it still produce reasonable numbers, or does it produce trash? LibSurvive builds on the FreeBSD Pi 2 once you mutilate the makefile a bit. Okay, that's still very wrong, but let's take a look at this data. Where is the data? Oh, here it is. That's super wrong, so that's mostly right. Let's see what happens if we do this in a different order.
If you have a vector, I really can't remember this. And you want to make a perpendicular vector, how do you do it?
You have to cross it with some other thing. Like, this is one vector,
Yeah.
but you want to make a vector that's perpendicular to
Yes.
it. You have to have another vector you tell it. So you say this vector, and now it'll give you a perpendicular vector.
Any other vector?
Mm-hmm. Well, it's got to be about 90 degrees from this
Oh.
vector. It doesn't have to be exact. It can be like this, and that's fine. You just have to normalize your answer. It's easier just to change the code and look at the outcome, because I've already changed the point where I was like, oh, well, the whole thing I was assuming there was all wrong. So, that's not right either. Maybe I have to put this after, or maybe you have to do something to mutilate the pose. Okay. would be.
I can see that causing a problem.
Because I'm from the lighthouse's point of view, so.
Console?
Good call. Still very wrong. That's interesting. Why is that in there?
The plate?
Yeah.
I don't know.
That's right. So let's see here. Oh, idea. So if I think that that's correct, we could do the same thing down there. I'm doing the same thing I did above down here.
Why? Just
That-
because.
I think that might be the key. Because they should nullify out. So it feels like this is algebraically wrong, but maybe we can salvage it. Where'd my data go?
It has gone a surprisingly long time without that happening.
What? Okay. That was weird. is this code here different?
Scroll down.
POS road.
You don't have a you were rotating by a LHP up there.
Right, but this is... No, I'm not. I'm rotating by OBJ from H. Oh. Well, which is just that. So... LHP is this. See, LHP... Sorry. Rote is from OBJ from that. Rote is from OBJ from that. Rote, POS. So the second time... Unless something's going on inside of Dave's thing where it's not zeroing and his thing's giving me a different answer every time. Maybe I should test that.
What, run it a couple times?
Yeah, make sure it gives me the same answer every time. If 1... I could believe that there's some code that's like accumulating something. No. Still, okay, so 0.41, 1.84, 0.41, 1.84, 2.3, 2.3. Yeah, it's giving the same answer every time. So when I run it, I don't know what I'm doing wrong here. They're both OBJ from LH. They're both going to LHP POS. LHP road. So, second time through, it should be the same data that he gave. Wait,
That's changing.
barely at all. Where? 23047?
It decreased each time.
No, 2035. Yeah, by like a millimeter. Oh, wait, no. Did I? Oh, I stupided. If not first cal. I just want to copy and paste the same code.
10:30.
I know.
Okay.
Oh, hi.
What?
It is the same number. Okay, that's not bad.
It was?
Mm-hmm.
Where?
I was looking at this number. It's actually this number
Compared to what?
compared to what the code up there was getting. So it is the same, so that's good. Okay, so... You know what we can do? We can subtract the 2. Um, wait, that would be. And then we would rotate by something, but I don't know what yet.
Yeah, you're just. Yeah.
Okay. This time it was accurate with it. It got the same answer to within a millimeter of the last time. That time it got it within a millimeter. Okay. We're cruising. We got something here. And
Yeah,
then,
this is doing your translation.
yeah, that's moving it back. So now, like, if
You have
I
to-
move that over,
You have to rotate that vector 180 degrees. Around any perpendicular axis.
no, I have to rotate that vector because it's going. If I move that way, it's going to move with respect to the way the lighthouse. Let's
Yeah.
move it. Let's move it. Okay.
Oh.
Okay. So move it to see the plus x on the top. Move it in plus x direction. Okay. Can you move the chair or something? I don't know. It's getting a bunch of nans. Oh, it's starting to get data again. Okay, so in one case it moved it in the plus x, and the other it moved it in the minus x.
What? Oh, relative to the lighthouse. Yes, that's correct.
Right. So we have to rotate that by the lighthouse vector or by the perceived vector?
What's the perceived vector? I mean,
Whatever, let's just multiply it by 1 and see what happens. Okay. Let's go. We're getting somewhere. Okay, can you move it back?
get out of the way.
Bunch of nans. So I don't know. It says it's almost a decimeter, negative 1. Move it, I guess, positive y. Like a lot, like maybe a meter. Yeah. That's not right.
So did you switch the rotations?
Mm-hmm. I seriously question if that was the right thing to do, though, but no, I think that's the right thing to do. Do you want to move it? Move it, I guess, in just y relative to itself. man.
Not right.
Oh no, give it a minute. It's gotta get the data back. No, it's not right. Well, no, it's not right. So close. 5 minutes. 5 minutes. Just 5 more minutes.
Want me to set a timer?
No. We're so close though.
I don't know. So this is going like that.
Oh, this won't work that way. Okay, it's out of order.
You mean rotation versus translation? What's out of order?
Hold on.
Really? I don't know about that.
Because I don't know anymore. Let's just try this. If this one does not work, I will give up tonight. See, is anybody still watching?
I don't know.
35. Yeah, everybody else is getting pretty tired of this. That's all wrong.
Okay.
Let's undo back to what it was, and then we'll commit. Let's make sure that's what it was. This part is all wrong. Okay, now it's at least back to 0. Yeah, he says the last moment before hunting is the favorite part, Josh. Okay, let's at least try to think about this through. So we have the vector.
And what's the origin? 0?
Okay, so the way it starts off is we treat the headset as the origin.
Oh.
That's the origin. Then Dave's code gives us where the position of the headset is relative to that, relative to the lighthouse.
So does that make the lighthouse the origin?
From Dave's code, the lighthouse is the origin.
Okay, that's good.
Then, so in order to figure out that thing's position in 3D space, what we do is we take that vector.
I'm telling you, all you gotta do is rotate the vector.
By what? Rotate which one?
degrees.
Rotate which one?
The vector from here to there.
I have that. That's what I do.
Right?
Right here. So that rotates it by 360 degrees, and that
Why
tells
would you
us
do that?
whatever 180.
180.
Yeah,
Right?
180.
So then it's pointing that way.
The vector is yes.
Exactly.
Yes.
And now you subtract the length of the vector. that brings it down to here,
Yes, that's what we have right now.
but it's not working.
It's not working because now we're operating within like pretending that's at the origin. So when we move that way, we're moving around in 3D space from that
From
thing's
that.
point of view. So how do we move around in
Wait,
3D?
why do, if we're like this, and then we translate it like this, why are we moving it like this?
Because what do you mean? Why are we moving it like that? That's just a way we can move it. We can move it anyway.
You mean when we physically move it? What are you talking about?
Yeah, when we physically move it. Oh. Okay,
It
so
shouldn't matter, that just changes the direction of the vector.
so we start with, from the lighthouse's point of view, that vector and its rotation. Then we flip it around. So now I have the 3D coordinates of the lighthouse. Yes. So now when he feeds me something, it's from the point of view of the lighthouse change. So if you change an X relative to the lighthouse. So
Oh. Why is it like that?
because I don't know how to explain that. That's just the way it is right now. We have to rotate. We never rotated back into world rotation. We've been stuck in lighthouse rotation.
Which should be fine, because that will get you the position of that in lighthouse rotation.
Maybe we get that and then we rotate it by the inverse of the lighthouse rotation. Because when we get a position from that, it's from the lighthouse's, like the lighthouse has a whole rotation like thing going on. And it's right now when you move in that like that way, it's saying, "Oh, I moved in that direction relative to my thing," which is totally different in 3D space.
Mm-hmm.
So it may actually just be as simple as a rotation. By the object. So
So you're going to rotate it by the object rotation?
yeah. Let's see, does that produce something useful to begin with? Move it. Okay, so that's off by a millimeter that time. Let's just try X, because that was a pretty good way to test something. Yeah, that was thoroughly freaking it out. Okay. Now it's, I don't know, I think something's really throwing it off. There's some bad value. No, it still looks like it's being rotated. Or, yeah, forget it. I think we might have to rotate like ahead of time and then do everything in world coordinates or something like that. Because right now we're operating in the coordinate local space of that. Yeah. I'm sorry, guys. We failed. This was a failure. We tried. Let's get things committed, and I'm going home.
You can stay if you want.
I gotta do church stuff in the morning. Poser Dave Ortho.c get add get commit dot update with almost working poser information stuff. This
Tired.
has been long stream to live. Goodbye.
At least now you'll get rid of all those weird artifacts.
We should probably just run that, calibrate. Oh wait, make clean all.
Make all green.
It's all wrong. Calibrate. Oh!
That's weird.
Why did it crash? Now I can't even. CTX driver CT.
Did I feed it like not initialized data or something?
I don't know. It's very broken.
Oh well.
Survive.
It worked for me.
I don't think it's your fault. I just see line 201. CTX. Oh, survive poll is null.
What? Did it not pick up the device or something?
No, this is the context. The context couldn't care less if the device exists or not.
What? I didn't change that, I don't think.
Actually, I don't even know how it got that far at all. You guys are inspiring. Ah! Why did you die?
Something's not being passed in correctly somewhere.
Okay, BT. Line 201. Calibrate. Okay, calibrate line 177. Yeah, why is that broken? What's going on? What? Is that getting corrupted, maybe?
Yeah, could be.
Where did you set this data up?
Right there.
That's bigger. That's good.
No, I didn't touch that one.
You didn't touch that one.
No, I don't know what that does.
Oh, that's fine. Whatever. What about the next one?
Yeah, I made that bigger, see?
32 times 3 bracket 2? Yeah, that's fine. Oh, this one, yeah, you made that one bigger too, so that's not bad. What?
Well, let's look at the part that I modified.
No, but the problem is in my code.
Well, why is it suddenly broken? It worked like 2 seconds ago.
Oh, remember, Valgrind is super angry. Wow, Valgrind is really angry.
I think you're just writing over memory somewhere in the stack.
Or something. How, though? Is not stacked or mallocked or recently freed.
Yeah, so you've written over it somewhere.
Survive.c line 201. Let's go back there.
You just have to clamp down the stuff in your
Yeah, I still have to
truck.
clamp down the stuff from my truck. What?
That sucks.
You're gonna have to Valgrind your code.
Alright. That's weird.
It's more Valgrind stuff. Ooh, hey, something useful. Nope, more. Okay. Oh my gosh, what's going on? I have an idea. Yeah, it's something in calibrate.
We'll deal with it later. I'll Valgrind my code on my own.
No, I mean, there's something in this file that's broken.
Well, just look at that and that. Those two, wherever they're used.
Jump offset times 2. Jump offset is just sensor ID.
That's weird.
That would break a lot of stuff.
That's the sensor ID.
Yeah, why is the sensor ID -1, -2?
I remember seeing -1 and -2 as sensor IDs at some point.
Whatever, I'm just gonna return from that. Hey!
I probably broke something somewhere.
Okay, well, I'm gonna just leave that there, and we will get diff.
Whatever.
Survive poll.
We should put a comment there saying fix this,
Yeah, let's do that.
because that's just gonna get buried.
We're not gonna ever find out why that was negative. Find out how this is. Actually, it's supposed to be negative sometimes.
Why hasn't it never crashed before?
That's a really good question. Maybe a lot of our other problems before had to do with that. Though I don't think our problem tonight had to do with that, so.
Well, you don't have all those weird, goofy things going on now. That's nice.
Yeah, that is nice. That's really nice, Josh. Actually, that really is nice. And our data is still trashed, so whatever. Fix Josh's accidental. Wait, that's not even your fault.
I don't think it's my fault.
Charles and Josh's collective bug. La la la. Goodbye, everybody. This was fun. See ya on the flip side.